Good afternoon, everyone. Welcome to GreenValley's LiProtect Open Day live stream. I'm Louis, the International Technical Director, and also I will be your host today. So thank you for joining us early. Today's session will be a little different. We won't go through all the specifications slides by slides. Instead, we will start from real-world scenarios and walk step by step through what LiDAR can actually do in real projects, from device to data, to applications, and finally to complete our solutions. Whether you are working in surveying, forestry, or construction, or you are just getting started with LiDAR, I think there should be something useful for you today. We also have several new products officially released today, in addition to LiAir, LiGrip, LiMobile, and also industry application device. So before we begin, feel free to say hello in the chat. Let us know where you are joining from and which product you are most interested in. And next, please welcome our Cody, the North American Operation Manager. And I think all the audience are very familiar with Cody. Cody, please say hello to our audience.
Hello, everybody. We're here in beautiful Beijing, ready to get the show on the road.
Also Chinese style, yes, traditional style, yeah. So, and one quick reminder, scan the QR code on the screen to book a demo. Once approved, you will save a 1 month LiDAR trial. And if you plan to purchase our product later, you will also have access to special event discount from 10%. So make sure to follow up on our channel as well, and we'll continue sharing more product updates and real-world applications. So, all right, I think we can move to our product introduction sessions. Let's move to our first product now, LiAir airborne scanning systems. We've brought all the devices here today. So Cody, I think LiAir has actually been one of GreenValley's earliest hardware product lines, especially since around 2020 when we introduced the V series, also the X series with intelligent Powerline following. So let me start with a very simple question. How has the product now evolved to what we see today?
Yeah, I'm glad you asked. So traditionally, the V70 was just a survey-based system, only capable of capturing RGB and LiDAR data. When we introduced the X series, we also introduced the ability for intelligence. So autonomous capabilities early on, leading to where we're at now.
Yeah. The X series, right?
Exactly.
So I think we have two main product lines in LiAir series, X series and H series. What's the main difference?
Yeah, so the main series with the X systems is the intelligence. So adding an AI chip built into it to allow for autonomous capabilities, where the H series is more geared towards higher altitudes, 400 meters or more, survey-based, survey-grade, high accuracy, single line beams.
And cost-effective.
Exactly.
Yes.
That's the main thing.
Yeah. The customer most like this word. So if I summarize that, I can describe the evolution with 4 key directions: more intelligent, more lightweight, more integrated, and more cost-effective.
Agreed.
Yeah, so now I want to ask the most important questions, and I think everyone is waiting for what are the new products in LiAir lines.
Absolutely. I'm excited to speak about the launch of some of our new products today. Today we'll start with the LiAir X4 Plus. Some of you may know the LiAir X4. The X4 Plus is the next integration of that system.
Yes.
We'll also talk about our new LiAir Xmini designed for smaller drones.
Mini, right?
Exactly. So we have our LiAir Xmini,
Plus.
X4 Plus. We have our new H600 Pro, as well as our new H600 multispectral.
Yes. So I think we can start with the first one, X4 Plus. Cody, I think X4 Plus is the next generation of our X4. So what's the main upgrade?
Yeah, so some of the main upgrades is the system is indeed actually smaller than the original X4, but with more capabilities. So we've added 3 different cameras on top of your traditional 26 megapixel photogrammetry based RGB camera.
Yes.
That's one of the key factors. Now we're able to capture 3D GS data as well as a fully integrated handheld system for this as well.
Oh, you mean this one?
Exactly.
Handheld kit. I think it's very different from the last generation of the handheld kit.
Exactly. So the last generation was cable-based with the external battery, a little bit bulky and clunky. This system is now just a plug and play with a single battery attached, making it super easy to go from aerial to handheld really quick and fast.
So this is the smarter battery?
Exactly, smart lithium battery.
Yeah. So how about the installation?
Yeah, super simple. So you just take the device, put it on, bam, system is ready to go.
Oh, so let me ask a very practical questions on behalf of our customers. Does the handheld need to be purchased separately?
No, I'm glad you asked that. So it actually does come with the purchase of the system.
Yeah, that's a really good gift, good offer. Yeah, so I think that's our integrated designs actually very straightforward venues. One less device to purchase and one less trip back to the field. We can collect both the handheld data and the airborne data.
Exactly.
So now, since the system works across both airborne and handheld, I think I will just talk about it already. Have we improved the installation and the user workflow for the handheld kit?
Exactly. So our traditional system, there was no direct communication with the app. So that's another benefit is it's now a part of the GreenValley app ecosystem. You can see real-time data from there. One-touch operation, super simple, as well as capitalizing on the 3 new cameras to get very good RGB colorized point clouds, even in a handheld mode.
Yes. How about the platform?
The
Should we manually switch?
No, so the other benefit of the system is that as soon as you switch it from handheld to the drone, it's automatically ready to go. No switching the platform inside of the software.
So it becomes a really plug and play.
Exactly.
Yes. So from application side, what kind of advantages does the integrated solution bring?
So several, I'm glad you asked, is the true ability to capture a scene. So not just from the air, but from the ground. Being able to merge those together seamlessly is really where this system stands apart from our other systems. So you get your airborne data, you get your ground data, all in one, lines up perfectly, and you get your true scene of the scenario.
Yes, so I think it's very important in our forestry and the surveying scenario because you know the trunk.
Exactly.
I think the trunk is very important in forestry applications because the segmentation, if we both use the ALS and TLS also in our software, I think the most more important complete data will be very useful for our post-processing side.
Exactly.
Yeah, so I think one of the most distinctive features of X4 series is its intelligent Powerline following capabilities, and I think we've been working on it since 2020. And this point is no longer a new feature. I think it's a can I say it's a mature capability.
Exactly. So several years of design and R&D has led to this.
Yes.
We started with the X3, now we're at the X4, and the full autonomous capabilities allows us for that extremely high success rate when it comes to power line management and maintenance.
Yes. So I think that's why our Powerline users can really rely on our Powerline following functions because it's not just visually impressive. We have many generations for this function, for this angry storm. It can actually perform stable and safe unmanned operations.
Exactly.
And maybe now we can go further. We are not just following the lines, I think. It's just the operation side. I think for this generation, we're also doing real-time components recognition and image capture during the flights, right?
Exactly. So for situations such as distribution lines, we're able to get very detailed, accurate images from above, past, and before the tower.
The channel?
Exactly. And as far as the sideline following, we're getting very detailed images of the line itself, plus spacers. The system even is built to automatically take pictures of spacers along the way. So you're getting a very detailed fine inspection report from this.
Yes, I think that's really important during our operations. It's all this, for example, the taking pictures, the live following, all these are real time.
Yes, yes. So you're getting some real-time data as well as some real-time reports.
So what's the still last page, because I recognize one important question. What's why we need to take this kind of pictures? What are the pictures used for?
Oh yeah, so they would be used for defect recognition. So being able to automatically.
You mean the defect on the components of the power tower?
Exactly.
Yeah,
the lines getting seen fraying and missing insulators.
Oh yeah.
So all the key
missing
components.
screws.
Exactly. All the key components, missing pins, things of that nature, can all be automatically recognized through our software and the hardware.
Yeah, so before we have this function, we need to fly it and then back to the office and organize all the data and to say manually say which one, this one is a component, which one is the component. But now we can automatically capture the image.
Exactly.
And also, I think we also have an AI platform to recognize the defect.
Yep, exactly. So automatic defect recognition allows for a series of different types of defects that can be recognized and then annotated, and also generate reports as well for that.
Generate reports?
Yes.
Real time?
Yes, real time.
So I think the customer is no need to post the process and to get the report. They can see the reports real time.
Exactly.
On the controller?
On the controller, and also saved in the project file as well. So things such as the real-time hazard point reports and real-time SAG reports as well.
Oh, that's really good. So from process letter to decide on site.
Exactly.
So that's why we say where the spatial intelligence really starts become practical. So now what if you are user only use small drone platform?
Exactly. So smaller systems traditionally were unable to have LiDAR on them, so they were purely relying on waypoint marking or autonomous flights. So yes, so we have introduced our LiAir Xmini, small in size, smart, capable of working with a series of different small drones, makes it super easy to show up to a location, launch, and get the data quickly without any bulky, large base systems. And this is pretty much where we're heading in the future. So
yeah, maybe we can take a close look. For the Xmini?
Yes.
No. Yeah, this one.
So.
So it can mount on the smaller drones.
Exactly.
So can I say this allows this small drones to handle professional work?
Exactly.
That's really
traditionally
impressive.
Just image-based, but now we have image and LiDAR as well.
So can we see the specifications? Yeah, you can see the weight.
382 grams, so extremely light.
Yes. So does this mean reduce the capabilities?
No, actually. So it maintains the capabilities, maintains the flight time, but gives it new deliverables that can lead to that professional work that you spoke of earlier.
So our goal is not reducing the capabilities, it's lowering the barrier of entry.
Exactly.
Yeah. So I noticed we also have our H600 Pro product here. So it's more serving forecast scenarios. What's the key improvements in this generation of H600 Pro?
Yeah, so I'm glad you asked. So the range measurement has been improved by 70%.
Yes.
So that's a big thing. Also added more points. So we're getting a higher, crisp, more quality detailed point cloud from the H600 Pro compared to our original H600 system.
So both range and beam advantage improvements. Does this mean it's a stronger performance in forestry as well?
Exactly. So better penetration, better coverage on the ground, also leading to better understanding of the canopy structure that we spoke about.
Yes. Yes. So in summary, longer range, higher point rate, better accuracy, and more suitable for project level delivery.
Exactly.
Yeah, so finally, I think this one is very interesting, and maybe I want to describe it as a industry application device. So it's almost a full package solution.
Exactly. So introducing the LiAir H600 multispectral system that encompasses 4 different sensors: infrared, multispectral, LiDAR, and RGB, like you said, to give a true applicational, real-world situation to one single payload.
So one flight multiple data dimensions, and when combined with our software, LiDAR 360, and we have a new module, spectral model. So it creates significant values in real applications.
Exactly.
Yeah, so that was a very quick overview of our LiAir product. Now I think everyone is asking the same questions. How does it actually perform in the field? So instead of talking more, so let's go to take a close look of our operations.
Absolutely.
Yes. Maybe we can take the device to here.
Exactly. We'll start with the X4 Plus.
Okay. Also, I'll take our H600 and MS. Oh, that's
A little heavy.
just a little bit. Yeah, so I think all the devices can be mounted on the M400 already.
Exactly. M400, M300, M350.
Okay.
As far as the H600 multispectral, it is only compatible with the M400 at this point.
Because of the weight?
Weight, yes. Weight and power.
Sensors.
Exactly.
Yeah, so we should start with this one?
Yeah, so we were just going to highlight the fact that the new X4 Plus, again, has the ability to connect to the GreenValley app. So super simple for anybody who's familiar with the GreenValley app. Very, very easy to use, available on iOS and Android. And you can actually see the real-time point cloud as well in the app, where traditionally we were unable to do that with the X4.
Yes.
So I'll just go ahead and remove it from the system, the handheld kit.
Okay.
Put this here, and then we'll go ahead and mount it to the drone as normal.
Mm-hmm. So the
Same mounting setup, so we still have our red and white to line up with the red and white on the actual Skyport itself. We just go ahead and put it in there. One twist and it's locked in.
Yes.
From there, we go ahead and connect the GNSS antenna.
Always don't forget the cable.
Exactly.
Also the SD card.
Exactly. So make sure that the SD card is in there. Make sure the cable is safe, out of the way of the props. Also go ahead and put in the additional power cable, which allows us to interact and operate with the drone itself.
Yes. Also we have red points, right?
Yeah, red points.
Yeah, finished.
Boom.
Really simple.
Yes. So from there, we'll go ahead and turn on the drone itself.
And then the device need to be powered on?
Yep. Yeah. So we usually let the drone just power up, do its initialization in the beginning, and then we'll go ahead and power on the X4 as well. The X4 itself is just a one-touch operation. Hold for about 1 to 2 seconds. The light will start to flash red. From there, we'll wait till it gets a green light, indicating that it's done its self-check and is ready to fly.
Yes. How about the antenna?
Yeah, so we have a single-based RTK antenna. The system can actually operate without the antenna utilizing the drone's RTK, or you can utilize a standalone RTK module, which is provided with the system.
Okay, that's perfect.
PPK as well, so let's not forget about that.
Okay. So maybe we can start to the
Start working through the parameters of the, so today we are going to do the above line and sideline following of the system. So we'll go ahead and,
yeah.
So I went ahead and powered on the remote. What we have is our friendly pilot here who is going to handle the operations for us. And I will go ahead and do the talking behind him.
Yes.
Maybe we can just clean that screen a little bit.
I have a paper, Cody.
Okay, yes, there we go. Here you go. Okay. Yep, so the first thing he's going to do is click on the autonomous Powerline inspection. Louise, maybe we'll have you move just a little bit so that you don't get hit.
You have this?
Oh, no, I was just meaning so that you didn't get hit by the drone.
So sweet.
IT 101, always refresh and start anew. And as you can hear, the remote is automatically indicating what is being done with the system itself. So we can see that there is an incorrect platform setting. GNSS is going to automatically correct itself.
I think we have some new functions on the app, right?
Yes, there's a few new functions, as well as making sure that the platform is correct. Single, yep. All right. So what we're going to do is go ahead and select the above line following. And traditionally, we were able to see all of the same standard settings that we have now on the above line. But if we switch over to the sideline, which we'll do secondary using the H30, and if we also look at the transmission and distribution, with the distribution, we can now see that there's an advanced setting inside of the GreenValley app that actually allows you...
new function?
Exactly. So a new function that allows us to change the frame rate or the frame ratio, rather, of the actual image that will be taken of the tower itself.
Yes.
So we want it to be as clean and clear as possible. So we'll put that frame ratio up as high as possible.
Yes, maybe we can click it here.
Yep, and so now you can see that there's an image of the...
how the image will look.
Exactly, so the image will be at a high quality. From there, we can look back that if we wanted to take different photos during distribution mode, we can change it between close or one mode or up to 3 different images that it'll take per tower. So depending on the flight time and the requirements, you can have up to 3 different images taken. From here, we can see that we are in the distribution mode, automatically set to 10 meters per second for the vertical. Horizontal, say you need to be further to the side of the line, you can change the vertical distance. Flight speed, we can preset, but this we're going to set it at 10 meters. And then as far as the clearance danger, we were talking about real-time reports, right?
Yes, yes.
So this clearance danger allows us to choose how far away from the power line we want a danger.
The danger distance.
Exactly.
Yeah.
So one of those benefits of the system there. And then the loss control mode, obviously safety features that we want to make sure if for some reason there's a disconnection between the remote and the platform, it will choose to either hover, continue flying, or return. We always choose hover because it's safest so that we can keep an eye on it.
Yes, for sure.
And then that's pretty much straightforward. Same situation for side, but side allows us to control the vertical distance as well as looking at conductors and spacers. If we wanted to stop and take those images of spacers that we spoke about, it can do that. If we want more focus on the middle phase, one of the benefits of the sideline following is the fact that it will automatically switch from line to line. So if you want it to be in the tower mode, it will just go to a tower, drop down, go back to the next one, and follow each of those lines.
Yes.
Or it can just stay on the same line, following tower after tower after tower, depending on the need of the day. So in this situation, we'll go ahead and confirm. We'll come back to, we're going to do above line, sideline following first, and then the voltage lines that we're working with, 66, I think it's higher than that, yeah?
That's right.
Yeah. So we're working with the 220 kilovolt. Unfortunately, the lines are pretty far away, and it is a cloudy day today, so we might not be able to see it from here. So we'll have a drone up in the air that's actually going to follow it and give us some real-time feed.
Yeah.
Yeah. It's saying...
Maybe we can take off?
Okay.
Okay. Okay. Is that okay?
Because it's saying incorrect.
Oh, okay.
Let's just do a final safety check on everything, make sure it's tight.
I think that will be clear for of the cable.
Yep.
So Cody, I have several questions from our comments and also from So what is the So for the X4 Plus, which drones currently support the Powerline following features?
Which drone? The M300 and M350.
So actually, this one is the M400.
Exactly. So over here we have the M300, M350, and also the M400.
Yeah.
The M400 does require the Manifold Platform 3 module in order to be able to do the autonomous power line following.
Oh, it's need additional accessories.
Exactly.
And then can support power line following
exactly.
features.
An additional module is required for that.
Yeah, and just now we see the side view Powerline following functions. What upgrades has been made to the side view Powerline following compared
Give me
to
just
last
a
year?
second.
Oh, you need to take off. Yeah, is that okay? So we can take off. Oh, be careful. Yeah. So,
Sorry about that, y'all.
Yeah.
Back in action, real-time situation. So
Yeah, so I think your mic has some issues, right?
Exactly. So
Yes.
yeah, we got that straightened
real
out.
world.
Exactly.
Yeah.
Real world scenarios.
So back to our M400 drones. I think we just talk about the side view Powerline following. So what's the main updates compared to last year's?
Oh yeah, so we've added the ability for sideline obstacle avoidance. So it shows an indicator line for the lines when following in sideline, as well as added channel paths. So you know exactly what channel the system is going to follow when it's following, giving you an indicator whether it's blue for the one you should follow or white for the one that's not being followed at the time.
Yeah. So we also have our handheld kit. So what's the biggest difference between the handheld solutions and other handheld systems on the market?
So I would say that the biggest benefit from the system is the autonomous power line following that the X4 has that traditional systems do not have, where you can scan a power line, then take it off, put it on the handheld mode, and do a tower scan or a substation as well.
So I want to highlight the difference between O2 and our X4 handheld kit, because I think it's based on the scenario you usually use. Because if you usually use in the building scanning, I think I recommend the O2.
Yes.
But if you are airborne data and then you need to submit some data collection between the building or the trunk, you can choose X4 Plus, right?
Exactly. So if you're doing the outside of a building, or if you need to get the entirety of the external surface of a building, then you're going to want to go with the X4.
Yes.
The X4 does give you that beautiful top and bottom view, which really encompasses the picture of what you're trying to scan.
Yes. Maybe I think our drone arrived at the site.
I believe so.
Yes.
So as we can see on the screen, the system is automatically adjusting the distance from the power line. We can see on the left-hand side of the remote that there is that blue channel path that I spoke about. Our previous version of the software required the user to actively turn the drone in the direction that it would be flying. Now it does it automatically. It also tells you right or left which way it wants to go. We can preset the capture interval as well as the inspection speed, and making sure that the photo overlap rate is at least 10%. One of the key new factors and features of the system is the autofocus. So traditionally we had to manually focus the camera to make sure we were getting that resolution of the details that we were hoping for. Well, now the system will automatically do a calibration, focus, and take off as we're seeing now. So as you can see, the system is completely autonomously operating and taking these photos along the way.
Yes.
It's coupled with the H30T, which has thermal, wide angle, and zoom lens as well. So we're getting all three.
Just now we select the spacer. So if we have spacer on the lines, it will be stopped and take photos automatically, right?
Exactly, and it'll even angle the camera to get the best view of the spacers itself.
And zoom in, zoom out, because we have function to adjust the angle and the distance.
Exactly.
Yeah. I think the image quality is really good.
Exactly, and as we can see with the system, we're able to see both the front-facing camera from the H30T, we're able to see the real-time point cloud that's being generated. We can also see a colorized real-time point cloud as well as a base map from...
Colorized?
Yes, a colorized base map as well. So if we go ahead and hit this, we'll be able to see, change it to color, true color. So that's okay. So we have color, we have elevation, we have intensity, all in real time. And as mentioned before, if there happen to be some danger points, such as trees along the way, we would be seeing those trees. We are also getting real-time tower points as well. Yes, exactly.
That's very advanced functions, I think.
Exactly.
Going back to
going back to the AI intelligence that we spoke about earlier, that's in the X system.
Yeah.
Exactly. As we can see, there was
the voice is beautiful, I think.
Exactly, the indicator voice that is exactly making sure that the pilot is always aware of what's going on.
Yes.
Just a few of the indicators on the system. We can see that this looks very similar to a pilot-based program. This is actually a GVI software specifically designed for our hardware. It works with all of our platforms at this point in time, but the autonomous Powerline following is only available with the X series. So whether it be the Xmini or the X4 Plus, both utilize this same software.
Oh, so Xmini can also do the live following functions.
Exactly.
Can I say it as a smaller X4 Plus?
Absolutely, yes. Yes.
It's easier for me to understand, for us to understand what's the position of Xmini.
Exactly.
So the difference is the platform.
Exactly. For those users who can't have the M300 or M350, or they have a fleet of matrices or Mavics, the smaller 3s and 4s, they're able to purchase the LiAir Xmini, operate as normal, get out there, put 10 up in the air, do an entire channel of towers in a day, which traditionally could have taken weeks before. So
yes, or manually.
Exactly.
Yeah.
And as we can see, the system did go to the tower, automatically drop down, and then now is coming back along that same channel, getting the second line below it. The beauty of this is that with every line that it takes, it's storing a new file. So for the top line, it is storing a file with the H30T and all the photos in one file, then named it down to line 2, and now it's storing a new set of photos and files in there, and the same for the third one. So it's very organized, so that when you get back to the office and you're looking to do your defect recognition, you can easily identify it was this line, phase spacer, we can see it there, and it's very clearly detailed. So when using something like Powerline, you're able to work with it much easier than traditional methods.
Yes. And we can submit to the AI platform.
Exactly, to run the defect recognition.
Yes.
And so for the sake of time of this demo, what we'll do is we will fly and do the sideline following, and then we're just going to automatically go to the above line following and do the above line following. In most cases, we would suggest coming back, doing and switching to the above line following. Exactly, battery, and just so that you have 2 separate project files. But for the case of time, we'll go ahead and do them both in one.
Yes, I think 2 separate files will be more convenient for us.
Exactly, yeah, because right now we're at about 63%. I think we're coming up on that next tower, which would allow us to do at least 2 towers of the above line following. So once he gets to the tower, we'll go ahead and end it and then start the above line following.
So no need to come back, we can continue the tower following, above following?
We will do it, yes. So for this case, we will do that.
Because our battery is...
Exactly, so we'll go ahead and end this one. Okay, and end it.
Now it's taking the pictures of the tower.
Tower, insulator. So it's doing its drop down, so it is going to drop down. And just so we can show the wide angle of this as well, so you have a good view of that, we can see the FPV. This is what's actually built onto the drone, and then we have the zoom and the wide angle. Currently, we didn't use the thermal of the H30T, just again to save time. And so this is we're doing all 3 lines here, so that's good. So then we can see the true picture of a tower to tower scan, getting all 3 lines, making sure that the image defect recognition is going to be able to recognize per span. And as we can see, that tower that we're seeing on the screen is actually behind it. So it's a different tower. It's not being taken away or corrupted by the tower behind it. It's staying focused on that close line, which is about 5 meters or so from it. So it's about 5 or so meters from that first line. And we can preset that distance, but for the best quality, we suggest the 5 to 7 meters or so from the line.
Depends on the drone size
Exactly.
and the local requirements.
Exactly.
The government's requirements.
Exactly, yes. Some governments...
The distance from the power line, I think, is important.
Exactly.
To check the rules before we fly.
Exactly.
Little tips.
Correct.
Tips.
So that's just toggling on and off the H30T's
So what's the function? What's this function?
So this is actually the H30T's laser rangefinder. So it's indicating that we are, you know, it's looking at it backwards, but we can see the distance, we can see the above surface level, and this is the reference from the H30T. And if we were to overlay the two of them, we'd see that the LiDAR and the H30T are lining up with each other in terms of distance.
So we will switch to another tower image capture.
Oh yeah, and this is a good representation of the
automatic extraction of the line.
Exactly. So that's what gives us that avoidance, so that we know exactly how far away from the line we are, what the system is seeing. So now it looks like we're heading back home.
We are banking home? Oh. We are going to bank. Oh, we need to change battery.
Okay, okay. Yeah, that's the thing about the sideline following is that because you're taking so many photos, high detail, high accuracy, it does use a bit of battery for it. And the battery wasn't 100% when we started as well. So yeah, that is one of the things. It is a timely process, but fine inspection matters, you know. So it's okay that it takes a little bit more time to do fine inspection, because the details of the fine inspection need to be as crisp and high quality as possible. So it's not a rush-based situation. So.
During this period, I think we can describe the H600 MLs and the H600.
Exactly. So we'll start with the H600 Pro. So new system, single line beam as the traditional. Single line beam as the traditional H600 was before. It's just this one has been greatly improved. So that 70% improvement, and the quality of the point cloud is much better.
Yes.
Roughly about the same weight as the H600, the original H600. So we're really getting a lot out of this system. Super excited about this to hit the market.
Maybe we need to bank a little bit. So our colleague will help to change the battery.
Perfect.
Maybe we can introduce the H600 MLs to our audience.
Yes, so super again excited about this system. The fact that we've embedded multispectral in with LiDAR and infrared really gives that the forest side of things a huge key factor. Being able to understand NDVI while also accurate measurements, heights, quality data, all in one system. So several use cases for this, and we're super excited to introduce it to the world.
Yes. I think this product is really special. And how about the specifications of the infrared?
Yeah.
The multispectral?
Exactly. So the multispectral is up to 14 channels. So we're getting a wide band, you know, of channels that we can play with on the multispectral, up to that near infrared, and then we also have that infrared camera as well. So we're getting a high level detail from multiple different sensors to provide one single source site that really can help the clients in the future towards ecological purposes and a series of different industry applications.
Yes. How about the installation?
Oh yeah, super simple installation. Same as the X4, just pop and twist, connect the GNSS, and you're good to go. Plug and play.
Right?
Yeah, absolutely. So actually, again, we had stated earlier, the M400 is the only system that currently is capable to utilize the H600 due to its weight. We do have a custom mounting plate for this system. So
3 points to Y point.
Yep.
And then 3 point with 3 points.
Simple.
Simple.
And then we'll go ahead and plug in our GNSS. As always, we have them color-coded, green to green, blue to blue.
Yes. How about the antenna?
The antenna is back here on the back. So we got a dual antenna set up with the M400. As always, you know, you want to make sure that if you're going to fly, you take off your sensor so that the drone can see even more so than it traditionally could with our M300 or M350 series.
If we want Powerline following functions, just now we mentioned we need another accessories mount on here, right?
Exactly, yes. So
Yeah.
that's provided from the manufacturer. It's the Manifold 3,
Yes.
which allows it to do the line following. It allows us to communicate with the drone to
Yes.
make sure that it's safe when in operation. So
Yes, but H series don't need this kind of accessories.
nope, yep, it's just pretty much
So
plug
it's
and play.
Long range.
Exactly, plug and play. And as well, the H600 series can be adapted with third party as well. So there is
that's
third party.
Very advantages, I think.
Exactly. So there's definitely a series of drones out there that are compatible.
Customer needs have the local manufacturers, drone manufacturers. They can have our H series compatible with their local drones.
Exactly. So that's something that GVI is always specialized in,
Yes,
right? Is the
yes.
ability to integrate.
Yes.
We
are
start
open
from
to
scratch.
all
And
customer.
exactly. So if you have questions or if you have a platform or a payload or a platform that you're looking to work with,
Yes.
reach out to us and we'll work with you on that
Yes.
integration.
Don't forget to scan the QR code.
Yeah, exactly.
Yes, reach
Make
out
sure to
to
scan
us.
the QR code. Reach out to the info at GreenValley.intl.com if you have any questions related to those specific products or the third-party integrations. So
Yes.
I think
Okay.
from here we'll go ahead and meet back with the pilot and
Yes.
go ahead and do that above line following.
Yes.
So
Maybe we can have a close look.
this time we're going to go ahead and do the above line following for distribution. So we'll get to see what it looks like while it's taking those photos of the towers. We'll go ahead and do 3 mode just so we can see how it handles taking one before, above, and after, so that you can really get the small insulators that are on distribution towers.
You mean the above, front, and back of the tower?
Exactly.
Okay.
Yeah, because you want to make sure, because if it's above, you may not be able to see strong details of the small insulators on distribution towers, where if you take if you look at it from an angle that's like this, you're able to see the tower from this way, tower from this way, and the tower from above.
Yes. Because different components also the different defect
Exactly.
in different position.
Exactly.
So we take different angles of the towers, and we can get different angles, pictures, and to detect the defect.
Exactly.
Yeah. Maybe we need to face this direction.
The video transmission project started. Start laser data collection.
So now what's happening is the system is automatically detecting the power line below it. As we can see, it has now detected the power line and it will start that flight. And it's preset to a specific height and distance. Users can change that, but we make it so that it can't go too close to the lines for safety purposes.
Finish adjusting the distance from power line.
So just now we forget to create a new project.
Exactly. Yes. So we
That's
did not.
Keynotes and the small tips.
Exactly. So small tips, making sure that you create the project before you actually start the flight. But here
Otherwise,
we're getting
when you finish, you think nothing. In the
exactly.
project file.
So we went ahead and started the project mid-flight, which we can see the real-time point cloud
Yeah.
coming from that. Not suggested, but it works.
Okay.
It works. You'll still get some data, and the key point of this flight is actually more geared towards the photos.
Yes.
So making sure that we're getting photos
Yes.
of those distribution lines is the key factor there. what we could see in that image view was that it targeted the tower. So it actually put a buffer box or a point of interest box around that tower to take those photos. And so now it's going to do the same thing again as it comes up to another tower, flies forward, finds that tower, creates the point of interest, and snapshots those things. This is actually nice. So it's indicating that there's a different line that it's going to try to bifurcate off of to, which is something that's beneficial about our software. So the autonomous Powerline side of things, it's never going to be that forever you have a straight line, right?
Yes,
You're going to have bifurcations that break off, and it's going to request for you to which way do you want to go, just like navigation, right? It's got a bright gray and a dull gray. The dull gray is, do you want to go this way? No, you want to follow that way? Okay, follow it. Another benefit from the software is the ability to automatically detect scissor crossings, which is lines that are crossing each other. So sometimes you have
different voltage.
Exactly. So sometimes you could have a distribution going under a transmission,
above,
exactly, or above, exactly. So the system will detect that above line or below line and determine whether or not it's safe to either fly under if it's below 7 or above 7 meters above the line, or fly above it. So it'll safely fly above the line while maintaining its track of the individual line it started with, come down safely on the other side of the line, and continue its path forward.
It's making decisions.
All in real time. Yep. AI driven by
Automatically?
driven by the AI chip that's built into the hardware itself.
So we can also achieve the spatial intelligence on the hardware.
Exactly.
Not only our software.
Exactly. So several features there.
That's what we call it intelligent.
Exactly.
Yes, really intelligent.
Exactly.
Real intelligent.
Yeah, so what we saw there was the 3-phase photos. So it created the point of interest on the tower, it took the first photo, then it flew above it, took another photo, went past it, and actually the camera tilted back. So it panned back to the image, to the tower, and took the photo, all while maintaining that same line of trajectory and lock-on of the lines itself. So that's what we're seeing there.
What's the box?
So the box is like a point of interest. And so, so actually we've got some danger points going on here. So it detected that there's some potential danger points.
Danger points and the distance?
Exactly. So we have tower points and we have danger points all embedded in real time. And we can see, so that's the list of the towers and the list of the danger points there. And now he just exported it out, already ready to go. And you can view that instantly right afterwards.
Even during the flight.
Exactly. So one of the use case scenarios for that is, say it's an emergency or a disaster response. Getting drones out there is much safer than having someone go out and walk the lines or walk around the lines, because there could be down lines. There could be trees that are hanging above those lines that are now a potential threat. So getting the drone out there, getting those real-time danger points.
This is also the danger points?
Yes.
Oh, it can show on the image,
exactly,
but based on the point cloud.
Exactly, using the point cloud to determine the distance, and then also overlaying that on the RGB images.
Yes.
So now he'll go ahead and return home.
I think another scenario should be fire.
Yep.
Mountain fire.
Exactly.
Emergency response.
Exactly.
This kind of scenario will be useful of our X4 Plus.
Exactly. So
maybe
as we know,
if customer has more requirements, reach out to us, and we can generate more functions to you.
Exactly. As we know, wildfires are happening quite often, more and more often with climate change.
Sure.
In places like California, we see those types of fires and emergency responses
I think
yearly.
Our device already used in the California fire.
Exactly, yes. Some of our devices have already been used in aftermaths of certain fires in California, which has been very beneficial. And we continue to hope to push that towards the emergency response side of things, because what we hope for is the safety of future residents, whether it be in California or elsewhere in the world.
Yes. I think we did a very short-term collection, but we already get the real-time point cloud, the real-time image capturing, and the real-time dangerous points, and the real-time report. Also, we have our read data, and we can post-process it to get high-quality data.
Exactly.
It's one flight to get a multi-dimension data.
Exactly.
Resources. Yeah, that's really I think useful in real world, real
Agreed.
project.
Agreed.
Yeah. So I noticed this one.
Yeah,
A
so
dock?
many of you may recognize what a dock is. For those of you that don't recognize what a dock is a system that can be set up pretty much anywhere that can communicate outside, so whether it be next door or
Yes.
where our potential colleagues are about.
Long-term maintenance.
Exactly. So long-term maintenance. So for power lines, for instance, being able to go out weekly, monthly, scanning. Say you're in a very remote location, it may be difficult to get humans out there all the time. But having a dock system allows for you to have a drone that can go out and do the same functionality as the X4 system, but with our Xmini system. So coupled with the dock platform, we're going to go ahead and do a demo of the Xmini as well.
Yes,
So
back to the table. So Xmini is compatible with multiple platforms, you mean?
yes. So there's
Even
this.
the dock and the general Mavic series drones.
Exactly. So Mavic and also the Matrice, so 4E, 4T, those are all series that are compatible with our Xmini.
Yes.
And soon in the future, other drones will also be compatible as well.
Yes.
Can smell that Chinese style tea over there.
Yes.
Smells delicious.
Yes, I think maybe we need to switch to this here. Hello, director. Please come here. Yeah. Okay, good. Maybe we can describe all the. Is it clear?
Can you see clear?
Should we need to plug out this? Okay, maybe we can.
Yeah, so what we're highlighting here is GVI's developed low altitude operations service platform. This is the online-based platform that allows us to communicate with the dock from a distance. So right now what we're gonna do is have one of our colleagues that's about 1,000 miles or 1,000 kilometers away from us go ahead and create a new project, walk us through it, and then we will go ahead and see the Xmini operating in real time. So Frank, we'll go ahead and have you create a new task for us.
Yeah, I think because of the on-site network issues, so we have our colleges away 1,000 kilometers of us, but they can still control our dock here.
Exactly.
That's crazy.
Exactly. Makes it even better. So if you do
Yes.
have those on-site issues with
Yes,
the
I will
servers.
call my college. Hi, please open the docks.
Exactly. So what we'll do
Yeah.
is have Frank go ahead and just create a base task name.
Yes.
So this would be the name of the actual project itself. So we can just call it where we're at, test or overall test 1, 2, 3. Equipment is going to be the actual dock. So you may have 10 or 15 different docks. You have them labeled, named as they are.
Oh, Cody, you are rich.
Yeah.
You have several.
I have
docks.
several, yes,
Yes.
several different nests. So we'll go ahead and choose the one that we're looking at here, which is the Honghe second generation Nest B. We'll choose the line, so there is a line off in the distance, distribution network line.
The line is the real power line?
Exactly,
outside?
yes. So it's a part of the Zhuzhou distribution network. So
Oh,
we'll go
yeah.
ahead and click on that, and then we'll start on the starting pole. So we'll choose starting pole 1, and then we'll go ahead and end at ending pole 4.
It depends on your missions today, maintenance missions. Today I want to collect all maintenance first, second, and third towers, right?
Exactly. So you may one day, like you said, need to just scan 1 through 4.
Yeah.
But then the next week you need a full new scan of 1 through 8. So
Yeah,
you can
yeah.
choose those. And in this case, we're highlighting that there is different types. So obviously we can work with transmission or distribution. So we'll work with distribution in this
Yes.
case. There is a remote control disconnect. So if by chance the communication between our colleague and the dock itself is lost, the system can automatically hover or land where it's at, or safely return back to the
But
dock.
we always choose.
Always choose hover just as a safe benefit. So
Yes.
and then the return altitude, always want to make sure that it's pretty high. So we're going to set it at about 100 meters so that really nothing that's going to get in its way.
Yes.
And so the next step that we'll do, we'll set it at 50 return for this one. Okay.
Based on the real scenario.
Exactly, yes. And so what we'll do next is we'll hit that certainty button. From there, we'll click on that project file. We'll open it up.
Maybe our dock is going to open.
Yep, so what he'll do first is kind of show where we're at, show that interface. Yeah, so we have the base map. We can see the location that we're actually at. We can see the towers that we're going to go fly to. Off in the distance, we can actually hear the beeping coming from the dock, and we can see the real-time feed showing up on where the dock is. We even have a little weather vane up there that's spinning to make sure that we know what the weather is at the time. The dock is officially opening at this point. We can see the drone now getting ready to start to take off. On the left-hand side of the screen are just a few functions for the drone status. We can see the battery of the drone. We can see the nose and the gimbal angle from the system. We can see the horizontal and the vertical speed, as well as some of the distance measurements and altitude.
Oh, you mean this?
Exactly, yes. So on the left-hand side, we got a lot of details that allow the user and the operations to continue working well. So the drone has officially taken off. We will go ahead and it looks like, yep, we're gonna, there we go.
So what's
Cloudy
the 1,
local
2,
server.
4 tower? Already have the tower?
Exactly, yes.
Oh, you choose 4 towers, so there are 2 towers here
Exactly.
on the base map.
Exactly. So it looks, yep. So yeah, so those are the towers that we have already marked. And so when you set up your system to do these scans, you're going to obviously do that initial scan, get them out there, and then it's going to continuously do those scans. So now we can see on our side that the drone has taken off. On the camera side, we see that the drone has fully taken off, and it will now head to the location. First, ascend to a safe location. As you guys can see, that it is a cloudy day, a bit rainy, a little bit of sprinkles that we're seeing right now. But it's actually still operating perfectly fine.
Yes,
that's the beauty of the system. Exactly.
Because the dog has always outside.
Exactly. So
dog 24/7.
Exactly.
So what's the distance?
So yeah, so that would be
the dock and the drone.
Yeah, and that's actually the vertical, the horizontal distance. So as it took off, it didn't indicate the height distance because that's on the left-hand side. But as soon as it left out of the horizontal of the dock, we can now start to see how far away that drone is from us. So currently, that drone is about 325 meters away. It is out of sight, but actually I can still see it way off in the distance over there. So that maintaining visual line of sight is obviously key. But we also have that drone that is following it, keeping that good eye.
See based on the drone.
Exactly.
Sight.
So there we go. So we can start to see some lines here.
Oh, it's clear.
Very, very clear. Very clear, and especially for again a cloudy day like today. And so the system is actively already going and tracking those lines.
It's finding the first tower?
Yeah, so it actually flew straight to the tower, locked on, and automatically went because it's based on a location. So unlike the X4 Plus where you just show up to a location, when using the dock, we already know the location. So it goes, it autonomously locks on and just follows it quickly. So as we can see, the distribution line and that those beautiful green fields behind it.
It's spring.
Yeah, exactly. Spring is looking good. The crops are looking good.
Spring.
Yes, I think that this is just a yep.
So now moving on the Xmini, the capabilities, which drones are currently compatible with Xmini?
So that would be the M4T,
M4E,
the M4E, the
M3D,
M3D, M3DE, and
M3TD.
Yep.
Yeah, 4TD.
Yep, exactly. And again, we will be looking to add a few more new platforms in the future. That's the thing about us, again, is that we're constantly innovating and integrating. So working with third-party drone manufacturers is the key moving forward because we want this to be as usable as possible for series and scenarios all across the world.
So it's already finished the commission? Because I already, he will find the four towers firstly and back.
Yep, so it decided to fly that back, and now we're gonna start to head back to the house. So at this point the drone is headed back to the dock. We can see it on the interface of the screen now.
And that's really clear. Maybe we can director, we can take a close look. The route I think it's very clear.
Very, very clear. We can see that this is the location that we're at. We got some good trees. We can also see the tents that are surrounding us at this point in time now. That big, bright, beautiful pink tent that's there in the middle. Definitely can't lose ourselves now.
Yes. Yes. If I write SOS.
Yeah, exactly, exactly.
Very clear.
Yell out, just look for the pink tent.
Yes.
So as we can see, the drone is now coming back. It is
Yeah.
actually heading directly back to the dock itself. It will land back in the dock, it will close, and it will safely start to charge again, get the benefits of a dock use case that you won't normally have as an individual who is flying or operating. That's the beauty of these dock systems.
Yeah. Thank you.
In the meantime, we're getting ourselves a tent to cover us because there's a bit of rain going on.
Yeah, that's a
Real world situation going on right now.
Also for our demonstration.
Exactly. Can never predict the real world situation.
Yes. I think my computer is gonna die. Yeah, so I think it's supposed to have a real-time point cloud because of the network issue. Yeah.
Yes, yeah. So there is
Hey,
also.
Frank, do we have real-time point cloud?
So now Frank is going to go ahead and show us.
Yeah. I know this button. Show real-time point cloud.
Exactly.
As real-time, not process point cloud. It's
Exactly.
different.
So right now what we're actually seeing is a replay of the flight that it just did. But while it's flying, we can also see the real-time point cloud that is generated. But this is actually showing the fully full real-time point cloud after the fact with the towers marked. We can see the location. Very, very clear. And then you can use this data later on for further analysis.
Yeah, it's only for the maybe on-site decision, but for our post-process, I think we have our raw data and then use our LiGrip and LiDAR360 or Powerline to process it to get some result from our software.
Exactly. The tool is just a tool, but the software is really where you get the benefits from it. So Powerline, being able to get high detailed reports, SAG analysis, a series of different tools, around 100 to 200 different tools in Powerline, specifically geared towards functions like this.
Yes, maybe we can have a summary for the Xmini because not only for the dogs, but also we can support the single small drones. For example, Mavic 4E, right?
Yep.
And to do the Powerline 4E. And I think in the future, maybe we can have a mapping version of the Xmini, right?
Exactly. So we're aiming for that fully autonomous capabilities of that system. So right now it is just designed for the Powerline following, but in the very near future we will have a fully autonomous version of it for subterranean and sub-canopy. And
we call it mapping version.
Mapping
this
version,
one should be Powerline version.
Exactly.
Yeah. So again, if you have more requirements, please reach out to us, and we can generate more functions of the hardware side, whether the hardware side and software side.
Exactly.
So let's back to our data.
Mm-hmm.
Yeah, we can check the data quality of our LiAir series.
So let's go ahead and exit out of here.
Yes.
We'll go ahead and pull up LiDAR 360.
Yes.
And so just for the sake of time, what I'll do is I'll go ahead and open up LiGeoReference, which is our free pre-processing software that comes with the purchase of any of the LiAir products. From there, we're going to go ahead and browse. We'll find that project folder. So the GreenValley April Tech Day, we'll come in here. We'll see.
This one?
One Tech Day. Go ahead, LiAir, and then we'll look at what we're going to do is process H600 Pro data. For the sake of time, it's just the quickest one that's going to process. So we'll go ahead and open up. We can see the file structure as we had stated before. It's all automatically saved on the device, ready and easy to use. We'll go ahead and click on this .li file. This .li file is actually the metadata file that, exactly.
You can read the parameters automatic.
Exactly. So if I click on that, we'll see that it's got a little loading page here. From there, we'll be able to see some lines drop in, our trajectory lines. From there, we'll target those trajectory lines, the ones that we want to work with today, and show how easy it is to actually operate with inside of LiGeoReference.
So we are going to see some data.
Yeah, let me go ahead and open up a new LiGeo real
Maybe
quick.
we can just click start.
No. We actually need to
Because the HDMI.
start this fresh again. So we're just going to make this a raw folder again. Start from scratch. Again, we'll click that .live.
Yes. Also, I also have several questions. Because we see 600 ms during the data collection, does we have real-time infrared imaging during the flight?
During the flight, yes,
Yeah.
So you can actually see the real-time multispectral as well during the flight. So
Yeah.
the quality is coming directly from the device, generating inside the GreenValley app as we saw before.
Okay.
So what we're going to do here is we're actually going to go in and select on the trajectory. So for this case, I'm just going to choose a few lines. Go ahead and draw these lines here. So I'm doing a polygon. We can actually also select manually. So if I want to, I can manually select on here with inside of the software. But I'm just going to do it the quick and easy way.
Yes.
So I drew the polygon. I'm going to split the trajectory. As we can see, we now have this split trajectory. And then we're going to go ahead and...
Clear the rest of the trajectory, right?
Yep, exactly. So we're just going to focus on the rest of the trajectory. So this one is unnecessary. So we'll click on that. We'll go ahead and delete that one. Clean up the the laptop. Yeah, I think it is having some rain rain issues. So we'll go ahead and...
Afraid my computer will be gonna have some issues.
Exactly.
But
So
this is real work.
Exactly. Yes, I think that the laptop is definitely seeing some issues here. So so I will go ahead and click on that, delete that, hide the remaining parts. So now we have just those focused lines that we want to work with today.
Yes.
Just for the sake of time, we don't want to process too much. So over here on the left-hand side, we do have settings. You can adjust the settings. You can make a filter. So if you want a specific distance that you wanted to process at, also some camera settings and post-process settings. We can select either from header, which is really a relative accuracy, or we can actually manually input it if we were flying with a base station that we have a fixed coordinate. We can put that fixed coordinate in here to get high accuracy absolute data results from this.
PPK,
if you use PPK.
RTK.
Exactly, yes. So, and you can also choose target coordinate system.
Yes.
So we do have a series of different target coordinate systems, but for this case, we'll go ahead and just leave it as is.
Yes. So if you don't need to do any advanced filter or any other functions, you can just one click, because when you import the live project, all the default parameters has read into our project.
Exactly. So, and in this case, we'll just run it all. We have that one touch click that you spoke about. So we'll run the POS process, georeference, as well as the colorization of the point cloud. So we'll go ahead and hit start.
Yeah, I received many feedback from our international customers. They say our software design is very logic.
Exactly, very simple. That one touch operation makes things really easy.
Yes.
So what we can see is that it's processing the DGNSS at this point in time.
Yeah.
So what I'll do is I'll actually go ahead and open up LiDAR 360, take a look at the multispectral results and the X4 Plus results, just to make it, pass time while it's doing that processing.
Yes.
So I'll go ahead and toggle off that H600 data real quick. And yeah, so we have, right now we're seeing the X4 Pro or X4 Plus handheld and
It should be X4 Plus.
X4 Plus, yes.
Because of rain.
I'm thinking so, yeah. Actually, that little bit of real world rain may have played a role there. So we'll see if I can go ahead and open up another LiDAR 360 and bring that out.
Maybe my computer will need change because of
updated.
this trip.
Exactly. This trip alone.
I can ask another new computer.
Exactly.
Boss.
I mean, with the way that the world is going, the requirements for computers.
The weather fault.
Exactly. Yes, and the way that the data is going, the high quality computers are necessary. So
yes.
We definitely suggest having a relatively powerful computer.
Yes.
I mean, I work still with the 3060.
Yes, because I think because of the multi-sensor of the H600 mLs, so the data size should be bigger
exactly.
than the normal model.
Exactly.
Still under process?
Yeah, that one's still under process. But
how about the electricity? Yeah.
Now we're open up here. So I'll go ahead and pull in that the X4 Plus data. So we'll come back and get to... Okay, there we go. So we did have ourselves a frozen screen there. Yeah, I definitely think the rain did play a pretty big role on it. So what we're seeing here is the data from the X4 Plus, both handheld and aerial. So if we were going to go ahead and toggle off that handheld data, we can start to see just the aerial data here. High quality from the air, looking really, really good of this facility structure. But what we had mentioned earlier is the real key factor and the benefit of the X4 Plus is that handheld plus aerial side of things. So that lining up of data, getting really, really, really crisp and clean RGB results from this system. So, so we can really easily read that.
It's handheld?
This is actually the handheld, yes.
With airborne. Oh, because we have absolute coordinate.
Exactly. So the lining up of those two is key. So this is, again, the X4 Plus, highlighting some of that clean, crisp data that we're able to get from it. If we go ahead and throw an X-ray on this just to get the real, internal beauty of this.
Oh.
Startled me. Yeah. Got a little bit of
X-ray?
some fireworks there. Yeah, this is the X-ray view. If we put it at something that's a little bit more visible than the RGB, this is where we can start to see that beautiful X-ray view. Let's go ahead and take it out of X-ray view. Get back to this intensity view that we can see here. That handheld side of things is just so crisp, so clean, super simple. We turn that off. We just look at the handheld side of things. Turn off the handheld. Look at the airborne side of things. Really, really, really are getting this exactly. Yeah, we're getting this really, really high crisp quality. Centimeter fusion between the two of those data sets. Love it. So now let's go ahead and actually add in the multispectral just to show a little bit of what is what we have inside of LiDAR 360 on that side. So. So as we can see the file formats here, we have the LiDAR data, we have the infrared TIFF files as well as that .dat file. So that .dat file is the multispectral file. We'll go ahead and pull this into LiDAR 360. For those of you that don't know, in version 9.1, 9.0, we did release a spectral module.
Yes.
That's a big advantage of LiDAR 360 at this point in time.
Module.
Exactly. So we have this spectrum module here that allows for a series of different things that can be utilized. So if we go ahead and zoom to this layer, so we have this two-dimensional TIFF file or this two-dimensional .dat file, which is that multispectral. We can go ahead and change the infrared or change it to the scanner, the additional, sorry. So let's just show the spectral profile. We can change the wavelengths, the index. There are several different tools that we can highlight with inside of the software. We can export those files. There are spectral libraries. So we have a series of different spectral libraries. You can also search for libraries, so you can utilize what's available. So we have some vegetation spectral libraries specific to certain types of spectral signatures. These are usually all available and publicly available data. As we can see, I think it's USGS data. So USGS allows us to see, the several different functions that are available within the spectral module, such as classifying by spectral angle, spectral index. So we have vegetation index calculator, NDVI, exactly. Index. So in this case, we will just focus on highlighting that there is that LiDAR data, the multispectral data that we are able to play with. In the future, we're going to have another webinar geared towards the multispectral to do a real deep dive.
Yes, for the H600 MLS itself with our spectrum model.
Exactly. And so it looks like our multispectral or the H600 Pro data is steadily chugging along there. It's about 16%. It's also likely taking a little bit longer because I got all these separate windows open, a couple LiDAR 360s open,
also
and MLS open up, in preps for what's to come. So excited to see these results. We'll continue looking at the data here. I'm afraid to actually run a separate processing out of this, so let's see. Let's choose this and see if we can just come in here with some vegetation. Don't really have much, so I'll just throw this in here.
For the H600 MLS itself, what makes the system stand out compared to other multi-sensor solutions? I think that should be it's highly integrated, right?
Agreed, yes. So highly integrated, and overall system is extremely strong. So
yes. Also, I want to highlight the control system and high precision INS, IMU, and all these sensors are integrated into a single unit, as you see. And also, it's lightweight, easy to operate, and supports real-time data collection and fusion. Yeah, I mean lightweight compared to other brands' product, the multispectral product. Also, so what are the advantages of the multispectral sensor itself?
Being able to break apart into multiple bands, so you really get an understanding of structures, of soil types, of vegetation types, being able to determine health of vegetation as well, which is something that a traditional LiDAR is incapable of doing. So adding that multispectral really gives it that higher spatial resolution and a total spectral analysis, providing for solutions and research, university research, for instance.
Yes. So wider dynamic range of spectral analysis.
Exactly.
Yeah.
And I worry about running that.
So maybe we can keep going to next part.
Yep.
Maybe, and this
X4 Plus.
X4 Plus.
Yeah. So we're getting there. Okay. So we've go ahead and we've completed this here.
Real-time process.
Exactly. So I'm going to go ahead and remove that from there.
X4 Plus or
this is actually H600 Pro. Yeah. So we're getting some pretty crisp quality there.
Profile.
Yeah. If I go ahead and make a profile, it looks like there might have been some birds
Maybe we can drop this side window.
Yeah. I'm going to change the intensity value to something that's a little bit more bright for the screen. So that way, when we run this profile view, we can really get an analysis of those returns. 0.1. So let's just throw it here. Yeah. So looking really, really crisp, really clean. See if we can find some vegetation.
We can find some trees.
Try to find some trees here. Yeah, so here. And if we go ahead and view this by return, We
time.
can see that we have multiple different returns here, up to
yes.
6 returns, that, unlimited waveform, which we tightly couple in LiGeo reference. You may be able to see a few more inside of LiDAR 360, but we can toggle those on and off. So you can still see that canopy quite well, that trunk well, that the DBH that we may be able to get from this.
Airborne LiDAR, you can see the trunk because of the returns.
Exactly. It's a really good data set with the tiered mounds here that we got. This would be a really good one to run some terrain on.
This is a real-time process.
Exactly.
As you can see.
Yeah, no editing.
Any other post-process functions performed.
Exactly. So if we wanted to run some measurements, we can do some measurements. We can do the calculation of a measurement, get some volume reports. If we wanted some volume here, we can just, draw an area and do that volume measurement and do it by cell size, loaded types, and we just compute it. And so now we have ourselves a volume measurement of this specific area here. We got the details related to that, the cut, the fill, the total.
Yeah. We also export a report.
Exactly, yeah. So and also too, in terms of like some of the tools related to it, we have a series of different reports. So density analysis, elevation difference. We can do a control point report, check the accuracies. We can also run trajectory reports, so we can see how the satellites were. We can see what the device was seeing at the time. Image overlap report as well for the RGB, and a series of different other things, all within inside of the software.
Even are just a free software
Exactly.
without hardware purchase.
Exactly.
Yeah.
So, and even if there was say it was a windy day and some of the lines were a little bit off, you can run a trajectory adjustment on it to make sure that those lines end up lining up well. So yeah, several different functions and features with inside of LiGeo.
You can see rendering as the GPC time and to measure the thickness.
Yeah. So we'll go ahead and display it by time,
Yes.
and then from there we can run that profile as well. And get it here. So we'll run it across this way just because it's each of the individual lines. There we go.
Perfect.
So we can see that real good tiers that are happening
Yes.
there. So we'll go ahead and look at this line here. Let me go ahead and make the points a little bit bigger. The point size a little bit bigger just for the camera to be able to see it. There we go. So that way we got this. And so we'll come in here, grab that measurement tool, and just, again, no additional editing here. So this is about, at max, maybe 0.5. Yep, about 0.5. So that's about 5 centimeters or so. But I would still typically suggest running that bore side or trajectory adjustment. It's going to improve the data. So you'd be able to see that in an RMSE calculation. So if we were to do something like the bore sight, run that calculation, we'd be able to see kind of what the software is seeing for that. It's behind this, so I can't actually see it. So yeah, so we got ourselves a 0.4 RMSE right now after after running the bore sight. And so if we pull this over here, get this out of the way, we can actually see this adjustment occur in real time. So that preview allows us to see the points that are here kind of loose leaning. The software will run that bore sight and tighten them up, making it even better. And then if we were to run that, allow it, process it, apply it, and then the same with the trajectory adjustment, we can get it even tighter, so that point cloud is as tight and as fine as possible.
Yes.
So again, the beauty of real-time processing.
Yes. I love real-time process.
Agreed.
To prove our data quality.
Exactly.
Also our function.
Exactly.
Yeah, that's why we can show the real-time process to customer, because our hardware has many improvements on our hardware, both our hardware and software, and algorithm.
Exactly.
Yeah. So I think that should be the main content of our LiAir series.
Yes.
Yeah. So we also have another new product. Yeah, this is also the first time I saw it. Oh no, I think I forget the application side for the LiAir series.
Yep,
Yeah,
there's still some
sorry.
applications to cover.
Yeah, because we need to summarize some applications to customer, what kind of applications we can perform our hardware and software.
Agreed. So yeah, we'll
Maybe
just
you need to
presenter mode. Yep. Okay.
Yeah, so now if we take one step further, there is no longer just about the data quality. I think at this point, we need to provide a complete solution to our customers. I think this is also one of GreenValley's biggest strengths, the complete industry workflow made possible by the integration of our hardware and our software. So could you please could you walk us through how these solutions are applied in real scenarios?
Exactly, yeah. So, I mean, utilizing something like the X4 Plus, for instance, getting an airborne and terrestrial data, you can really get the overall understanding of, say, a forest canopy or a forest structure. So getting branch and trunk data, being able to run individual tree segmentation inside of the software, getting DBH measurements with individual tree reports. All of those are features and factors that allow for a better understanding of forest canopies, research purposes, like similar to the project here that is being referenced, a university breeding project.
Yes.
So 2 days, 300 acres, using the X4 Plus handheld kit and the H600 Pro device. We were able to merge those two together to get really, really high quality DBH, create stand parameters, regression analysis. We're getting a lot of data, a lot of results from those systems.
Also our LiDAR 360 software?
Exactly, yes. So utilizing LiDAR 360 is where we're going to see all of those tools really come into play.
I can see the most powerful forestry software in the world.
Yes.
Can I see that?
I would agree with you there. I would agree with you there. Maybe some have some tools and other tools, but
Yes,
none of them really have all of them.
The whole package.
Exactly.
A complete package for both ALS, TLS, the forestry applications. Even now we have spectrum module.
Exactly. So leading into that, the spectral analysis side of things. So LiDAR 360 spectral module really does give a very strong argument for why to use multispectral, because you're able to do multiple things with it, right? So getting NDVI, NDBI, spectral images as well, really just helps you a scenario or a situation that may previously not been able to be done, because with LiDAR and with just RGB, our eyes can only see so much. So the spectral analysis side of things is great.
Between us and others, because we not only provide the hardware, we also compared with software with the functions to customers. Yeah, thank you. Maybe we say too much.
Yeah, might change.
Yeah, test 1, 2, 3. Okay. So go ahead, Cody.
Test 1, 2, 3.
Yeah, it works.
All right, and so moving on to another industry application would be related to mine safety, right? So having a point cloud data, being able to generate volume measurement reports, making sure that a mine area is actually safe and then also usable, right? So whole point of the mines are to make money, right? So being able to calculate the volume and the measurements of those, the stockpiles. One of the beautiful tools in LiDAR 360 is the segment anything model.
Real world customers, in the end, customers only need the report.
Exactly. That's really what it comes down to.
So we provide a very simple functions to customer, one click to output the report.
Exactly.
That's the delivery of a whole project, I think.
Agreed. So I think we'll talk a little bit about topographic mapping.
Yes.
So one of the earliest modules within inside of LiDAR 360 was the terrain module. It's likely
Our
outside
terrain
of
module is very powerful, I think.
Agreed. Yeah, and outside the forestry module, I think it is the #1 purchase module.
Yeah,
I think
agree.
it's the
Totally
most
agree.
useful. And this is just an example that was done 13-kilometer corridor. We had some challenging terrain, utilizing the LiAir H800 for this actually, which was a system that is still being sold from us. 1.2 1.2 billion points, 9,300 high-resolution images processed, 1 meter contour generation at a 400 meter flight height with 16 GCPs to ground truth that data to make sure that it was as accurate and as reliable as possible.
Also, we provide GCP report in our version 9.
Yep.
Yeah.
Exactly, and can even automatically target those GCPs. So
Yes.
it makes it much easier to, quantify and quality.
Quality.
Yeah,
Yeah.
exactly, of that data. So.
Yes.
And I believe this was done somewhere in Southeast Asia. One of our clients that we worked hand in hand with, and with LiDAR 360 as well.
Yes.
And then moving to the building modeling side of things, so LiDAR 360 and also LiDAR 360 MLS,
Yes.
both have functionalities geared towards specific
Building,
features for
yes.
building modeling. As we can see here on the bottom left-hand side, we have that X4 Plus data from above,
Yes.
from the
Yes.
ground. We're able to get those measurements that we want, so the facade measurements. And then on the right-hand side, we also have this beautiful building
I
that
think
we...
the data are collected by you, right?
Yeah, actually. So this is a library.
Library.
Yeah, Daniel's building in Toronto.
Oh.
So I was able to capture that with the X4 handheld kit and panoramic kit. And then the team kindly was able to create a 3D Gaussian
Yeah.
model out of it. And it looks fantastic. And then from there, we took the
Yeah.
Gaussian model, did some drawings. And now there's this side of this building that, wasn't known before. So.
Yeah. So both our LiDAR 360 and LiDAR 360 MLS has building model. What's the main difference between these two models?
Yeah, so I'm glad you asked that. So
Yeah.
the building model in LiDAR 360 really is more of like an aerial approach, right? So getting building footprints, getting
Yes.
the texture
And the
of
modeling.
buildings. And then MLS is more geared towards like the indoors. So
Yes,
like
yes.
the 3D building modeling, Revit, getting a true model of the inside. We have automatic vectorization, so floor plan automatic vectorization. So if you need just drawings, we
Yes.
have these automatic functions to be able to extract them very
Flow
easily.
plan extraction.
Exactly.
So I would say the vector side and can combine with the kit software. Then choose our LiDAR 360 MLS software. And if you are going to do the building modeling with texture, so I recommend you choose LiDAR 360, right?
Agreed.
So also one thing I want to highlight, our software is a general platform, not only for our hardware, even our pre-process can correct other brands' hardware data.
Yes.
Yes, that's very important notes on our software ability.
Exactly. I mean, at the end of the day, GVI truly started as a software company.
Yes, you are right.
So being able to
Especially
provide
LiDAR 360.
exactly,
Yes.
exactly. So
Yeah, I know many customers use our LiDAR 360 to do some pre-process to correct their hardware data.
exactly,
Yeah.
whether it be from mirror
Yeah,
angle effect or
trajectory,
trajectory.
adjustment.
Exactly.
Yeah.
Exactly. So yeah, LiDAR 360 really is a powerhouse of a software and MLS as well. So
Yeah.
And even further with Powerline.
Yeah,
So yeah, so that will pretty much cover, I think, what we had for the LiAir products. So.
yeah. So what we are really doing in LiAir series is bring the whole chain from data intelligent collection and to analysis and to final output further forward, making it simple and increasing automatic. So that's really the core idea behind the way we build solutions. And I'd also ask everyone watching in your own projects, what matters most right now, and the efficiency, accuracy, or automation. And please feel free to leave your answer in the chat, and we can talk about it more detailed later. And if you'd like to apply this workflow to your own project, you can also book a demo directly through scan our QR code, and you can also book a demo directly from our info email, and reach out to us, please, and we're happy to go through the setup with you one by one. Yeah, so just now we walked through our LiAir series and how high precision and intelligent airborne systems are used in real projects. But in real scenario, I think there's another type of demand. This is complete different. What if there is no GPS? So for example, in mines, tunnels, dense forestry, or even environments where people cannot enter safely. So is there a system that can go in and do the data collection job for us? So next, let's to introduce another key product in GreenValley spatial intelligence, LiAir.
Yes, yeah, super excited to talk about this product. So as you can see it here on the table.
Here is the LiAir.
LiAir, yes. So it does have LiDAR, it's got ultrasonic, but the key function behind this is the brain inside of it, right? So as you know, as the screen says, smart brain, high performance cerebellum, and also synergistic energy. So really it's designed to go into those areas that you can't safely navigate, think for itself, and make the decision safely to get that data that we are looking for.
Yes. So what's the core advantages of LiAir?
Yeah, so I mean, some of the core advantages are the AI that's behind it. So a millisecond level response decision making is huge. Make sure that in the real time you're able to capture this data safely, knowing that the device is going to come out, right?
Yes,
so that's the whole thing there. No learning curve, so it's super simple. You just pretty much create your boundary and let it go, and it does the work for yourself. And then major hardware upgrades, portable and durable as well. So super simple, IP53 protection rating, dual flight handheld modes, and a complete system that's a single person can carry, combining durability with flexibility.
Yeah, so LiAir is designed for very challenging environments. So I assume the hardware stabilities and environmental stabilities so also are very critical here, right?
Exactly. Yes. So making sure that it's got high protection rating, right? So it can, if it needs to, it can touch walls and things. It can handle some rain. Some mines obviously have moisture in them quite often, like what we're seeing right now, this mist. And being able to operate that way seamlessly is huge. That dual operation mode as well, the handheld mode to balance large scale mapping with detailed spot checks, long battery life and high definition recording, so 2K or 4K with the movable gimbal, and also a smart remote control. So that remote that's handling everything, the real-time point cloud that you're seeing there, the marking is all super beneficial from this. So that 6 nanometer chip is really the control powerhouse of this system. So
yeah, so through the case specifications briefly.
Yeah, so basic specification, 2,900 kilograms. It's rather large but small as well, not nearly as big as something like the M300, M400 that some of our competitors require to operate in autonomous conditions. That camera with the pan tilt, both 2K and 4K, getting ultra high def in that 4K. The smart battery allowing for up to 25 minutes of flight time. You can get a lot of data from that. Traditional large scale drones were around 25-30 minutes before the M400, as well as the LiDAR. So having a LiDAR that's producing up to 200,000 points per second with the range.
Is used for navigation? For
navigation and also for mapping. So you're getting both out of it. I mean, for surveying. So you're getting both out of the system from that. So
yes. Yeah, I have other points need to be highlighted. So I think there is the 4K camera is optional. So I think it's used for the low light environments, such as indoor, underground, or light operations. The 4K cameras provides a better sensitive and clear image. So for normal outdoor conditions, the standard 2K configuration is also sufficient.
Yes. Yes. Yeah, that 2K is perfectly fine, but the 4K takes it to a whole nother ultra level.
Yes, yes. So how does this specifications translate into real capabilities?
Yeah, so I mean that independent decision making, right? So being able to actively make its own decisions on the fly to safely navigate is huge. Having a panoramic camera that also allows for real-time video streaming, the individual can send that drone out to a place that they can go, but maintain visual line of sight with that, or non-visual line of sight, but visual transmission feed line of sight from it. Being able to 3D reconstruct, so real-time reconstruction. Me?
Yeah, it's okay.
Okay, 3D, the 3D reconstruction, so real-time point cloud that you're seeing, real-time visualization of the environment itself, and then location inspection, right? So centimeter level precision, positioning, and automated inspections that can be done on a routine basis. So
Yeah, here, because you just mentioned the 3D reconstruction. Yeah, here I want to highlight one capabilities in particular. This is built over a decade of GreenValley's SLAM experience. So whether it's real-time SLAM or post-processing, it ensures high-quality point cloud data, which means once again we are delivering an integrated solution from hardware to software and algorithm of the application.
Exactly.
Yes. So now let's look at it from another perspective. I think we can start from real operation pinpoints.
Exactly. So again, that real-time monitoring allows for the capture
the
of point cloud. Exactly. Fully autonomous exploration. So being able to, again, just set it out there, let it go, and allow it to explore for itself. Exactly. Precise precisioning as well. 7-centimeter level accuracy in areas without GPS, right? So you're not able to get in there, no GPS, but being able to send that drone out there to get that data is incredibly efficient, as well as the efficient obstacle avoidance. So you want to make sure that it doesn't hit these obstacles.
It's important for the autonomous drones.
Exactly. They got to think by themselves, but they also got to know what's around them to avoid them as well.
Yes.
So it's one thing for it to be able to fly by itself, but to be able to make sure that it doesn't crash into a wall or a small line or a small branch or something is very critical. So that takes that level that even some humans might not be able to do because they can't actually see that small detail. But yeah, this drone is capable of doing that. So
yes. So for the real industry, we can say we can help our audience to understand this system by the pinpoints and our solutions.
Exactly. So yeah, some of those pain points of traditional systems: limited navigation, passive sensing, high-risk operations, and low efficiency. But with the LiAir A, boundless flight, so completely independent of GPS and external communication, autonomous exploration like we've mentioned so far, no waypoint planning, safer placement for machines entering complex areas where humans just should not be going, so zero-risk operations, and ultra-fast mapping. The speed at which this thing can move through a forest or a sub-environment is quite astounding, actually.
So autonomous exploration, I think it's like a person entering an unknown space and moving while building an understanding of the whole environment. So no prior data is required. It's a critical capability.
Exactly. So yeah, just being able to truly understand an environment without the human input is quite extravagant.
Like our brain.
Exactly.
Yeah. So maybe we can look at some real case.
Yeah. So I mean, this is just gonna highlight a few things. This is a
real project.
Sample data,
customer.
Exactly, yeah. Based out of the Henan province, they utilized it to collect rapid 3D points for a underground mine. Super high efficient in the surveying of these abandoned mine areas, where traditionally, again, humans should not be going. So low cost, easy to use. It really only requires one person, two people. A couple hours of being on the site, where traditionally could have been couple days, right? So it's really beneficial device.
So I think mining is very typical scenario for LiAir, this kind of device.
Exactly, yeah. So just continuously, highlighting the side of
different mines.
Exactly. So different scenarios, different mines. There's different situations for these mines, different use cases.
Results.
Exactly. Different deliverables that this one system is capable of doing, and then again coupled with our software for those true deliverables that you're getting as the result. It's a very powerful tool, and really is where the world of AI is going, right? So just super happy about it, super excited to talk about it. So we have some further analysis. So in tunnel environments, fully autonomous drones can replace human workers.
Tunnel mining.
So super efficient tunnel detection, so post-disaster detection, as well as smart mine modeling. So
yes.
So you just
another applications for the stopping, secondary stopping.
Yep. So after stop blasting, you're able to get a significant discrepancy between the actual stope profile and the original design. So being able to send this device in there to make sure that it's safe and get that result in real time with CAD drawings is a really beneficial thing.
This kind of result can be imported with Kits plugin.
Exactly.
Because our LiDAR 360 ML is software has CAD plugin. So when we finished this vector extraction or calculation based on our automatic or semi-automatic tools, then we can export this result to CAD through our plugin.
Exactly.
Yeah.
So it just continuously,
It's same like our customer system, right? Because one thing I want to highlight is whether it's the LiAir A system itself or the result generated through our software, LiDAR 360 MLS or LiDAR 360, they can all integrate seamlessly with customers' existing smart mining systems under our the SLAM structure.
Exactly.
Yeah, framework. This is not about strong hardware. I think more importantly, it's about software and customers' whole solutions integration, making the data truly usable and deliverable.
Agreed.
Yes.
Agreed.
So I think it's a summary for the closed loop in the mining industry applications.
Exactly, yeah. So just pretty much highlighting, that closed loop management system, really just an overall ecosystem from 3D visual reconstruction, blasting and secondary stoping design, backfill management, and remnant ore and 3-level reserve analysis. So
yeah, I think we have another very practical scenario: stockpile measurements, right?
exactly, yeah. So stockpile measurements, we're getting that GOF measurement.
It's still mining?
Still
but
related
you
to mining.
calculate the efficiency.
Exactly, yeah. So calculating the efficiency, overall comparison of efficiency for the monthly GOF monitoring. Traditional methods, conventional total station, 16 hours, could cost roughly about the same, but time is really where that it's the timing is everything, requiring 2 individuals. 5.3 hours or so for a handheld system, where with the new LiAir A, fully automated, around 5 minutes. So we're really getting a really good, strong response from this.
Yes. So for the stockpiles, the pinpoints to help customers to understand the applications.
Exactly. So yeah, that blind spot and risk.
Maybe I need to notice our stuff. Maybe we need another umbrella.
Yeah.
Yes.
Yeah, we're getting heavily rained on here.
Yeah. So maybe we can continue and.
Yes, so blind spots and risks, so the safety hazards, risk of falls and stockpile collapses during manual climbing, data inaccuracy, so poor representative sampling leading to massive estimation of errors, and operational risks, so rigged flight paths causing high collision and crash vulnerability, where the LiAir A allows for 360-degree total inventory solution, ultra-fast operations, 1,000-meter square stockpile scanned and explored within 5 minutes, comprehensive scanning, 200,000 points per second with 360-degree coverage for precision mesh generation, and the business value, right? Eliminates estimation errors, enabling dynamic scheduling and $1 million annual savings.
Yes. So I think maybe next page. I think our O2 and the LiProtect can also do this kind of scenario job. So what's the difference between these 3 devices?
Yeah, I mean, so our the LiGrip products, really, it still requires in most cases the human interaction, right? Which is totally fine in most cases, in a lot of use cases, but in situations
and for accuracy result.
Exactly, yeah. So the high level of accuracy that we get from the handheld systems is definitely going to be the differing factor. But
so we highly don't recommend the total station.
Exactly. Yes.
Really
time consuming.
And time consuming.
Yeah. Not gonna.
Person consuming.
Exactly. Being able to really just bring it into the new age of autonomy is really where we're aiming
so we
for.
provide a different kind of autonomy.
Exactly.
Yeah, handheld and the UAV scanner, and also our LiAir A total or autonomous drones for different scenario.
Exactly.
Yeah, maybe Cody, please go ahead. I will inform our staff to
please
have another umbrella.
Yeah, so I mean, just continuing on that. Sorry, it is starting to heavily rain here, so just making sure that we are keeping our equipment safe over here. But yeah, so another continuous side of it is the stockpile inventory. So exponential exponential efficiency gains, revolutionary data precision, and comprehensive management upgrades. So over-the-shoulder view, exploration progress, side view, and live action shooting. So a company uses the LiAir A to conduct inventory scans in its bulk storage warehouse, which we are seeing there. Technical analysis of fully automated and unmanned, a brand new AI exploration architecture. Inference per frame takes only 2 to 3 milliseconds, significantly improving data processing speeds and enabling millisecond level response times, as well as that autonomous path planning that we've mentioned already. So without the need for pre-programmed flight paths, creating waypoints, just creating that electric fence or that geo zone that system stays in, and then it will just safely navigate it, such as this indoor stockpile facility that we have here. Another use case would be that of
forestry. Also,
exactly.
Forestry can use LiAir.
Exactly. So yes,
that's interesting.
The forestry side of things is extremely beneficial because getting the subcanopy, which we still suggest the use case of the O2 and the O2 Lite for this.
Yeah. Because for the natural forestry, I think it's dangerous because I think the autonomous fly in mining industry and the forestry industry is totally different, right?
Yes, exactly. So
because I think the leaf,
exactly,
different.
leaves the location of trees vary, right? So
yes.
We still do suggest
always consider as obstacle for LiAir A. So we totally recommend the O2 and our LiGrip series and the LiProtect series if it's natural forestry. But it's manually forestry, I think we can recommend the LiAir A.
Exactly, and even some forests, they have large spacing between the trees, right?
Yes,
so
yes.
It could be a natural forest, but it could have large wide spacing, high branches. So really, we're just going for that DBH.
Yes.
Still may be able to use this system. So. So surveying plantations, right? Navigating dense forests to pinpoint locations, adaptive GNSS denial, extremely efficient and automatic capitalization. So some of the industry applications that we've already mentioned, as well as some that we haven't, the natural landscapes, warehouse and logistics scenarios, as well as urban and tunnel scenes. Breaking the final physical barrier of 3D spatial data, redefining data collection standards for the low altitude economy moving forward.
Because you mentioned the urban and the tunnel scenario, so I think there's some non-street and lake distinct features. So although we have optimized the LiAir A for such environments, but we recommend limiting continuous flight distance to within 2 kilometers to avoid potential position loss. So, but if the environment is too open and the lack of the features, we recommend to use our O2 instead, because our O2 has the MLF SNAP algorithm, but if still have some features, we can have LiAir A.
Exactly.
Yeah.
And then.
Yeah, this is LiClip.
Exactly.
Yeah, that's interesting.
So that would be the system that's right here in front of us.
So it's scissors?
Yeah, so it's pretty much cutters, right? It's smart-based cutters that are designed for efficient pruning, right? So being able to get into areas high up in the trees, to be able to capture these very early, I would say, early life of the branches to get these measurements. So so the LiClip systems, high pruning UAV system with precise positioning as well as a lightweight design. So some of the key factors is the sample recovery, right? So being able to get up there, as I was mentioning, into the branches high up where humans really can't go, take a clipping from it and bring it back down safely for research purposes.
Oh, so the cutting tools is used for collecting leaf samples.
Exactly, leaf and branch samples that we're able to get from high up that in cases you don't want to send a human out. The branch is too thin to be able to get up there, and traditional methods just do not work.
So if we didn't have this system, the task traditionally is manually?
Yeah, manually climbing, manually cutting, maybe throwing a string up there trying to catch it, but you're not.
Yes, but I think samples need to be collected from very top of trees in some scenario or some development. So manual clipping is neither safe or stable.
Exactly. as mentioned here, the traditional high altitude pruning, extremely high risk,
Yes.
multiple blind spots, as well as super inefficient, where the LiClip solution, zero risk in the long run, full coverage with intelligent vision system, as well as high frequency. So robotic arm operates efficiently, significantly increasing the frequency of maintenance. So being able to do it more often with less risk. So the system itself, super lightweight.
Specifications?
Yep, super lightweight. So 320 grams, ultra lightweight, 125 low latency. So that millisecond level, neural reflexes, as well as, up to 3 kilometers of a remote control. Not really going to suggest that too often, that people,
Yes,
are trying to clip these little tiny branches at 3 kilometers, but you never know. There could be only one launch location and one fly location that they have to get out.
Especially for the mountain.
Exactly, yeah. The high mountain or dangerous ravines, they may want to get down into an area that they can't get to. So having that range is a key thing. So
one thing one important parameters about the 100 to 25 milliseconds latency. The core value here, I think, is real-time responsiveness and precision. If the delay is too high, the drone may drift due to the wind or the movement, and the cutting tools may fail to align with the target branch. But with this 125 milliseconds, so the system delivery of what you see is what you get experience, greatly improving success rate and operation stability.
Exactly.
Yeah. So in summary, the core capability is fast, stable, and precise sampling.
Exactly.
Yeah. So as drone is not just a drone, and I think it's more like a micro robotic arm operation in the air.
Yep. Yeah. So it really is just a tool that is bringing it to the modern age, right? So a traditional tool, hand clipping, it's just not beneficial. But bringing it to the modern age, using technology to make sure that it's as accurate as possible and safe as possible, as mentioned in river valleys and cliffs and those areas where humans should not be trying to collect these types of samples. So
yes. So another question people often ask: so what about extreme environments? Dense forestry, cliffs, high altitude areas. Have these scenarios been validated?
Exactly. Yes. So. In the past, it is incredibly dangerous to try to put someone down into a ravine where they can't actually even get down there safely without ropes or something, right? So being able to put a person down, being able to put a device down in those ravines and be able to capture these samples in critical areas is very beneficial. So making sure that we as a company can provide that to users was the goal behind the LiClip.
Yes, safe solutions. So what we see here reflects years of deep forecast in the software, in the forestry sectors. We are transforming high-risk, low-efficiency manual work into safe, maintenance for coverage intelligent workflows.
Exactly.
So instead of talking more about parameters, I believe what everyone really wants to see is how these systems operate in real operation. So maybe we can switch to the outdoor demo.
Yep.
Yeah, because I am also excited to see the operations. This is my first time to see the system.
Amazing.
Yes. So let's go.
Yep.
Yeah, we can bring the system to the site. Yeah, if our customers have some questions, can leave in the chat. Yeah, I realize we are starting develop more equipment based on the entry-level drones.
Exactly.
That's really reduce the barrier of entry.
Exactly. So as you can see, this is on one of the tree series,
Yes.
And it is the system that is being sold here is the LiClip, which is just this tool and the communication device
Yes,
with the
the model.
Exactly, the module.
Yeah.
And then we have the LiAir A here, which
integrated systems.
Exactly. So we're walking over here to this pretty dense little playground that has multiple obstacles. I'm excited to see it fly here.
Yes.
This would be as real world
challenges,
scenarios. Exactly.
Real challenger.
Real challenges, real world scenarios.
Real.
With some rain going on too. So. We told them it would be a real live demo and real world scenario. So we're getting this down.
But not this kind of real.
No, we were not hoping for the rain.
Yes.
We were hoping just for a nice little day, but
yes.
That's GVI 101 though, as we work, in real time on the fly and we get things done. That's the reality. So
yes, maybe we can introduce the system to customer firstly.
Yeah.
The structure.
Yeah, so the structure is designed to remain safe, right? So it has these protectors, blade protectors on the outside. They are carbon fiber, so that it can actually hit, things if it needs to. But from my understanding and what I saw, it is not going to hit them unless it's very, very small, right?
Yes.
But we do have a mid 360 sensor on the top of it as well. That's allowing for, as we talked about, the navigation.
Yes.
But as well as the mapping that we're going to get from it too.
How about the bottom?
Yeah, so the bottom, we have the camera on the bottom. We also have ultrasonic sensors as well that can...
Ultrasonic sensors used for
a supplemental, so in cases of like water, right?
Yes,
so the LiDAR itself is incapable of detecting the water, but having ultrasonic allows it to be able to detect water. So, and it does have a battery, pretty large battery on it that allows for that, I think 25 minutes or so that we mentioned earlier. So we're excited about this product. It's obviously, new to the GVI ecosystem. So we're ready to get it out there on the market. And
we go to the spatial intelligence.
Exactly.
Yes. Maybe we can start, and maybe we can take a close look at the controller. The process of the...
So this is the controller that comes with the system. As we can see that it created a base map. So right off the bat, we created a base map. The system is creating a base map, which gives us that ability to mark what we want to do. There is different parameters from either very detailed or very rough. So if it's a detailed map, we're just going to look at it as a detailed map. So right here, what we're going to do is create that electric fence. So we're going to get the electric fence from the system. We created our little base map going on here. And now we're going to take off. And we'll go ahead and move back a little bit. Right now we have 2 different drones up in the air. Takes a few seconds. The device is going to go ahead and start, take off. And at this point it's operating completely autonomously. So it's going to find itself, it's going to find where it wants to go, which right now is back home. I'm thinking there might be some weather related issues here with the rain. Maybe we'll refresh it 101, right? That Tech 101, just refresh, start anew.
Do we need clean up the device?
The lens from the raindrops, maybe. Don't take off.
Don't take off, just collect. Because of the weather.
Yeah. So we're gonna go ahead and clean it up a little bit just for this purpose. There was more rain on it than we would have anticipated naturally.
How about the ultrasonic? You need to clean up? Because if it detects the water.
Exactly. Yes, that's true. Yeah, maybe it is indicating that it's detecting that. So. And that ultrasonic's there on the bottom. So there we go. Now we're getting a much better visualization. So
this is the base map.
I think it just sat over there on the table getting rained on a little bit too long. So
thank you.
Oh, well, thank you.
Maybe
got my umbrella. Ella. Hey. I mean, the quality of that real time is just amazing.
It's amazing.
Just from sitting there on the ground, right?
For the site decision.
Exactly. Okay, so now it's gonna take back off.
Try again.
Try again, that 101, right? There we go. So it's on its way. Right now what it's doing is mapping around, seeing the environment, safely navigating through. And as mentioned earlier, it's doing it quite fast, right? So it's not like a simple, very slow, human movements. It's fast. It's moving very, very, very fast and rapidly through this environment.
No manual operations on the controller. No manual operations, and also our real-time point cloud.
Exactly. So we're getting the detail from that. We're seeing the real time coming through, as well as what we're going to be able to see later, which is that end result, the LAS file that we're getting from it.
Yeah, this detect the people, so stop.
Exactly. Detected us, was able to flip around and safely come back to the same exact location. So really that's simple, right?
Really fast, really simple.
Exactly.
Really stable.
So let's just say we scaled
the real-time point cloud.
Exactly. And say we scaled that up to, a much larger area. That would have done that in about 2-3 minutes, right? This was 30 seconds that it flew and was able to capture this whole entire little park. So quite impressed by this system.
Yeah, so I think we can move to the LiClip part, but the LiClip are not suitable for this weather, I think, but we can see the structure and the takeoff.
Exactly, yeah. I think that the LiClip side of things...
Hello, director?
Maybe not so safe today.
Yeah. Yeah, already...
But it's up in the air now.
Takeoff? Yes. Yeah, so... we will find the trees, the leaf. Maybe we can see the controller.
Yep. Yes. Oh yeah. And actually, we got one of the best pilots in China right here. So I think that if there's anybody that can get this done on a day like today, it'd be this gentleman here. So
we can take a close look. Hello.
Camera guy.
Yeah. Hello. Yeah.
There we go. So we got that, close-up precision, being able to get, as close to that little branch as possible. And the reality is that even with the human eye, it's a little hard to see. So having some operators that are telling him, where it's at. I mean, again, he's such a good pilot, he doesn't even need that. He's on the branch now, initiating the clip.
Yeah.
It is clipped, and now we have the sample. And now, if you want to see the sample that has been captured from the device itself,
you can also see on the screen. Yeah.
Yep. So we can see that it's got a little piece
on the screen.
And then you can see over here, back on the screen.
We have a sample on the scissors.
And so now the goal is to get that sample back to us.
Yes.
And as you can see, this guy is operating this drone in environments that
very cool.
typically wouldn't even fly at. So look how cool that is.
Wow,
we have
so
this straight sample that is just hanging out on this piece here. Amazing.
Amazing. This is what GreenValley do.
Exactly. That is the whole purpose of that. So you can see those young, we'll call it young branches or stems that are coming out of that. That's what's used for the research purposes. The goal behind the LiClip.
We provide safe solutions to customers.
Exactly.
Yes. Maybe we can come back.
Yep.
Yeah.
So we'll go ahead and head back to the...
Thank you. So let's
Amazing job.
Amazing job. This is what we see in spatial intelligence.
Agreed.
Yes.
Agreed. Yes. So being able to the digital realm back to professional-based research, right? So taking that little piece of sample may change the future of a species, right? Knowing and understanding that species is
for the ecosystem maintenance.
Exactly.
Because our founder, Mayor in our founder is a professor. In the ecosystem industry.
Exactly.
So we have detailed solutions to our customer, to our forestry applications customer.
Exactly. Yeah, that was impressive. I really like the LiAir A, you know, that
Yes.
ability to just move through an environment without even thinking about it, like as a pilot, and then the side of the LiClip, right? So just being able to, again, get into like deep canyons or caverns and things that, you know, traditionally us humans shouldn't go in at all,
Yes,
let alone,
yes.
you know, attempt to go in. So
So this is what we see full stack solutions, ecosystems of GreenValley.
exactly.
So,
Whew.
yeah, we need to change the mic.
Yep, okay.
So, just now I see the real-time data quality of LiAir is really impressive.
Yes.
How about the post-process of data?
Yes, absolutely. So another thing that's beneficial about our software, you know, is all these different devices being processed and
one
handled in one
software.
software is just incredible.
Yes,
So
incredible. Yeah. What are you looking for?
the pen.
Yeah, okay. The pen.
Thought I lost it.
The pen.
Okay, so
Okay. So, let me clean up the screen.
thank you. Okay, so let's go ahead and open up LiDAR 360 again. We still have that data from earlier, and now what we're going to do is go ahead and bring in that data from the LiAir A of that scenario situation that we were just encountering. So this is the process data again through LiDAR 360 MLS. We are able to get this data processed, and let's put this back at 3D. And yeah, we're super wet over here. Everything is pretty much wet. So yeah, so we're getting a chance to be able to see this environment, right? So this is pretty much what that system is going to see itself, right, in real time. But we're also able to see it. Let's change this to intensity. Change this to this. There we go. So look at those structures. Just look at the quality of that. I'm just so impressed by what the system is able to do in such a short amount of time. Getting those results. Let's look at this again, and let's just say take this out of X-ray mode. Take it out of EDL. Those points are a little too big. Let's pull it back down. Let's see. There we go. Again, so no additional editing, no processing, no filtering. This is just the data that's coming directly
Only
from that
process.
device. Exactly. Coming
So
directly
it's
from that device.
processed by our LiDAR 360 MLS BP module?
Yes, exactly. So just same as our O2 products, we're getting that same level of results from it, but again at an autonomous level. So adding another factor to GVI's full stack of intelligence that we're getting. It really is
Really
good.
good.
Really is good. And again, safely navigating. And I'm not sure that the audience was able to see all of these lines, right? So there was all these lines that were above and around that system was still able to safely navigate around. Some of those
Yes.
lines are maybe like 10, 15 centimeters wide that the system was able to see, navigate through. We did a flight earlier and it was a bit chaotic, and I was actually, my heart was pounding when it was happening, and it still handled it so well. Like
Yes.
it's just, I'm so impressed by the actual
Yes.
results from it. So yeah, super excited about the systems.
Short term, it can finish the data collection.
Exactly.
Yes.
I'm just gonna wipe my laptop here a little bit.
Can I see the trajectory?
Yes, of this one, no, it's not loaded in.
Okay. So let me make a summary. LiAir represents the transition from manual operation to autonomous decision making, and LiClip represents the transition from perception to physical action.
Exactly.
So together, they redefine how work is done in the industry, turning high risk, low efficiency manually process into safe, minute level, scalable intelligence, spatial intelligence workflow. So just now we've seen several different forms of spatial data collection. In many real projects, everything eventually comes down a very specific situation. The operators is already on site, the environment is complex, and the working distance is short, and both detail and accuracy requirements are very high. So in this case, the system that actually carries out the task is often a handheld SLAM device. So now maybe we can move to closer and talk about one of our GreenValley's core products, LiGrip handheld LiDAR systems. So Cody, let's start from the name itself. You are still involved of the data quality of LiAir.
Yeah, that's
I think
we're all here
really
for
love this system.
We're all here for the data at the end of the day.
Yes.
So I'm happy to look at it and let me pull up the LiGrip PowerPoint. Wrong one.
Yes. Right click.
Yeah. Open up.
No name. Yes. So I think LiGrip is almost core product in GreenValley's ecosystem. So let's start from the name itself. Today, besides introducing new products, we also want to help everyone understand the whole product line more clearly. So could you break down the name LiGrip for us firstly?
Absolutely. So the Li part obviously stands for LiDAR. Pretty much all of GVI's ecosystem start with Li, as we heard. LiAir, LiClip,
yes.
LiDAR 360, LiMobile, and then the grip side, right? So handheld, right? It means grip, grasp, being able to grab a device and just walk with it. So that LiGrip was a no-brainer at that point.
Yes, that makes sense. So actually we started working on SLAM-based LiDAR system quite early. So from backpack systems to handheld system, this has been a long development path. Could you walk us through how LiGrip evolved?
Yeah, so I mean, as mentioned, as early as 2016, we were one of the very first SLAM-based systems on the market with our C50 at that time. So single-base
backpack C50?
C50, yeah. So at that time, single-base scanner utilizing Velodyne. Had a camera, no camera actually at that time.
Yeah, really?
So it was as basic as possible,
Personally,
right?
I haven't seen the system.
Yeah, we still have this same system on the showroom floor in Berkeley, actually.
Really?
So yep. So
Berkeley office?
in the Berkeley office, still have this system on display just
You
to show
must
this
take
roadmap.
pictures for me.
I will. I definitely will. So to 2021, we released our first LiGrip, which was the V100.
Oh, yes, I know
so that first true, rotating head based SLAM device, single head sensor. To 2024, 2025, we released our LiGrip 01 Lite.
Yes.
And then
it's a really impressive product.
Exactly.
The O series, the really first integrated system of our LiGrip series.
Exactly. So moving from that cable and battery, just like the X4 handheld, to that fully, all-in-one system. A battery that is a handheld, the RTK antenna being attached to the release of our, most cost-effective version, which is the LiGrip SE. So.
Yes. So I want to emphasize the point we built everything from the ground up. So algorithm, hardware, our GreenValley app, and software, of course. That's why we can provide a complete end-to-end solution to our customer. So what is the core position of the whole LiGrip product line?
Yeah, I mean, that high precision, really. So high precision, simple, easy to use, fully integrated, all in one, with a high focus on surveying, construction, forestry. So one of those key factors.
Yes. So exactly, and because of its practical position, I think LiGrip achieved a very strong performance last year.
Agreed, yeah. So, I mean, we sold 2,000 plus units easy in 1 year in over 137 countries and collected over 60,000 kilometers worth of data with the LiGrip. So, and also received several awards, 2024 Top 30 Most Innovative Products of the Year, as well as 2025 Digital Intelligence Pioneer Product Award.
So I think this is a tool that has been truly used and proven by our global customers.
Exactly.
Yeah, so we also received a very consistent feedback from our users worldwide that will summarize it well, easy to use capabilities in real work and ready for delivery.
Yes, yeah, that's exactly how we define the product. So
Yes, yes. So let's start with the first point. Easy to use. What does that really mean?
I mean, yeah, at the end of the day, the easy to use side of things is how quickly can you pick up the device and go, right? So
Yes,
having
yes.
an app that's downloadable via iOS or Android
Yes.
means you don't need an additional tablet or device. Easy to use, easy to operate, one-touch operations. So no need actually for the app. So say your phone dies, right? You're in the middle of
Yes,
nowhere, your
yes.
phone dies.
If I don't want to use my phone,
Exactly, or you don't want to use your phone, right? So
especially in the rainy day, I don't want to take out my phone.
exactly. This is a perfect scenario for that situation. So the
Yes.
device actually allows for the one-touch operation built onto the back of it. So we can
Yes.
power it on, we can start the collection, we can do GCPs.
Even GCP use the button.
Exactly. Even the GCPs
Yeah,
can use the
wonderful.
button. So one-touch operation, quick and easy.
Yes.
Exceptional battery life though, so that's another thing about the easy to use, the really truly built for work. So up to 2.5 hours of operation with the single battery on the SC model, and up to 5 hours of operation with our with the backpack setup. So the backpack setup allows for dual batteries, which can be hot swapped, right? So you can be in the
Yes,
middle of
yes.
working and hop swap those batteries. So technically you can work endlessly. If you got 4 or 5 batteries, you can scan all day long just using that hot swap capability. So and then yeah, so that built to work side of things, that
Yes,
level of accuracy.
Yes, I think this point is actually the most important for customers. Whether the system can truly do the job, to be very direct. Many products in the market focus on competing in price or some specifications, but what we promise to our customer is this: no matter if we provide the entry level, mid-range, or high-end flagship, high-precision products, what GreenValley delivery is always a system that can actually do in real work.
Exactly. So that high level of accuracy, that precision, absolute
Yes.
accuracies of 3 centimeters or greater, repeatable accuracies of 2 centimeters or greater, and a
Yes.
relative accuracy, really, of 1 centimeter between those points. So
Yes.
high stability is really what we aim for. Just highlighting that level of accuracy. So between 2 scans, right? So doing 2 different scans, that concept of repeatability, right? So doing 2 different scans, same path. We're seeing an armacy of one of them of 1 centimeter and another one of 2 centimeters. So sticking to that repeatability of 2 centimeters or so, with a total absolute accuracy of around 3 centimeters.
Yes. So I want to ask another question based on this page. Next page. Yeah. So why is horizontal and vertical correctness is so important?
Yeah, I mean, I'm glad you asked that. So at the end of the day, right? So if
Yeah.
we're building buildings, right? And we have
Yes.
multiple floor buildings. If you're off even by 10 or even 15 centimeters,
Yes.
your building's not going to last very long. It's not going to
Yes,
stay.
yes.
It's not going to stay up. So
Yeah.
having these types of accuracies and really understanding previous projects as well, like as builds.
Yes.
Did this person actually build the project right? Right.
Yes.
So let's verify that this person actually made that building to the standards of that blueprint. So
Yes, this is why we say our system is deliverable.
exactly.
Yeah, so I think this page shows the precision methods, right?
Exactly. So that the factor behind what I said about the C50, right? So that was purely a SLAM device, right?
Yes,
It had
yes.
nothing else. Like
Yes.
there wasn't the ability to geo-reference it other than using control points and whatnot.
Yes.
But now we have that RTK, PPK, MLF SLAM. So we have
Yes.
multiple different fusion factors
Yes.
coming into play with these devices that lead to a much better accuracy,
Yes.
a much better result, less overall flaws in what is traditional SLAM drift. So
Yes, yes. Our goal is try our best to have the data map successfully.
Exactly.
Yeah, help customers to reduce the repeat collection work.
Exactly.
So I think this page shows different precision methods, and many people are familiar with RTK SLAM, PPK SLAM today. So what's the difference in our project approach of the RTK SLAM, PPK SLAM?
Yeah, so I mean, really, it just comes down to the use of high detailed or high accuracy, high quality RTK fixed solutions to constrain SLAM. So preventing jump points, where many other companies are just using it as a like a reference point, right? It's not really the actual like guts behind it. So using that RTK to focus our SLAM algorithms to make sure that it's as accurate as possible is really what we go for.
So you mean we will filter high quality RTK to RTK fixed solutions to construct the whole SLAM
Exactly.
trajectory?
Yes. Exactly.
So also I think another point is that our algorithm is fully self-development by ourselves. So we don't rely on third-party software.
Exactly. Keeping it all in-house is really what it is. I think that's where we've excelled with our SLAM algorithms, is because we didn't reach out. We saw a problem and we solved it internally.
Yes. So I think there's another thing many projects teams care about: the data stitching, layering, and the large-scale continuation.
Exactly. So.
Oh, still GCP. I think I missed some pages.
So just to highlight the MLF SLAM side of things,
because
right?
it's the key points of our LiGrip O2 series.
Exactly. So highlighting the MLF SLAM side of things, GNSS SLAM and Visual SLAM, being able to work in open areas really, is where SLAM used to fail without features. So because SLAM utilizes features, so that MLF SLAM really is taking things to a new level. And then GCPs, right? So GCPs are also always beneficial, right? So using GCPs can never be a bad thing, right? You're truly referencing yourself, and the device makes it super simple to capture GCPs. Drop it on a known point, push a button, and within 10 seconds you have yourself a GCP.
Even use the button.
Exactly. So and then now moving on to the question you asked about the data merging and the layering, right?
Stitching.
So stitching and bringing together multiple projects, utilizing our breakpoint continuation function feature. We're able to do multiple projects, bring them together, and prevent that layering effect that was traditionally seen in projects. So so data without GNSS requires merging to form a complete data set. Now we have that system where we can capture 3 or 4 different projects at a time under one project file, process it in tandem, and then have it all land in one place, right? So almost like an automatic registration of traditional tripod-based systems can be recognized with inside of MLS now. So that's a huge benefit. I see, yes, our team here is bringing over all the components of the LiGrip. This is wonderful.
Yes, our O2 series has mobile kit, front pan kit, back pan kit, even airborne kit.
Exactly, yes. So
we cover all scenarios.
Exactly. So the system that is truly the multi-fully platform, it would be the O2 platform that allows for the drone kit as well, and the mobile kit at higher speeds, right? So and as well a robotic dog, right? So working with the future of autonomy is a big thing. So continuously working on that merging and working in an ecosystem where we can highlight things that weren't traditionally possible before. So so highlighting the SLAM. So
I think GreenValley's we all know GreenValley's strengths in algorithm. So what's the key advantages in data merging?
Yes. So that rainy laptop. Okay.
Yes. Sorry.
Oh gosh. The rain is just. Oh my goodness. The rain pushed us like 20 pages somehow.
Okay.
Oh. the key thing. Save time, save space. Could I get napkin?
Paper?
Yep.
Yeah.
Okay, perfect, thank you.
So after data collection, does customers still need to buy additional processing tools or softwares?
Not really. I mean, the pre-processing side of the software, which is LiDAR 360 MLS BP module.
It's powerful enough.
Exactly. It's powerful enough. 50 plus free point cloud tools, from coordinate conversion, generating volume reports, plan and elevation drawing, just, creating blueprints, orthophotos. All of those are features and functions that are built into the pre-processing software that comes with the purchase.
Yes.
Just as an example, the volume report that can be generated, which I highlighted earlier, inside of LiGeoReference. Same
Even
with inside
the volume calculation is free?
Yes, yeah. So this is a part of the software. You get that volume to reference plane or volume between surfaces and enclosed volume reports as well, all within inside of that software for free. So
yeah. So the third point, ready for reliable delivery.
Exactly.
So
Go ahead.
Oh, and go ahead.
Yeah, so I mean, the ready for delivery really just means like, what can you get from the device, right?
Yes.
And really
also from the software.
Exactly,
Yeah.
from the device and now from the software, right?
Yeah.
So taking that data from the tool to the building of the house, right?
Yes.
So the cluster processing with ultra fast high speed, we can generate SLAM results, mesh results, 3D Gaussian results with an increased speed of up to 90%, even from previous generations, just 7-8 months ago. We've updated and increased our software to handle even larger outcomes at a higher rate of speed. So one software solution for all three, LiDAR 360, MLS deliverables, as mentioned. Top left is a 3D Gaussian model, middle is a mesh model, and then on the bottom right we have unstructured or even structured E57
Yes.
outcomes. So the one software really does handle a lot.
Yes.
And that one-stop solution with direct output of deliverables, no switching required. So you can stay inside of MLS to do the pre-processing and then
the
directly
post-process.
Exactly, directly open up the pre-processing with inside of the same software
Yes.
to generate such things as the architectural drawing that we spoke about earlier, point cloud classification, such as the difference between branches and trunks. So
Yeah,
we
even
have
this.
that park-based
Yes.
classification. BIM modeling, so built-in, like you said, CAD plugin
Also,
or
we
Revit
have
plugin.
Revit plugin.
So
Yeah.
taking that three-dimensional model, and again, forestry individual tree segmentation really is that powerhouse, right? So getting those reports, knowing each individual tree, the location, the details about the tree, the crown area, crown volume, DBH, all these are things that we can get from that single
One
software.
software. Yeah. So we've covered the overall strengths of our LiGrip series. So now let's move to the most excited part, new product release. Cody, what new models are we introducing?
Yeah, so we're going to introduce our LiGrip SE, which is the latest model, which we just released over the last month. The LiGrip O2 and the O2 Lite. Starting with the SE, we have some highlights, which is that it's an exceptional value for the money, right? So at the end of the day, it's just compact, powerful, with survey-grade accuracy, still has those two 12-megapixel RGB cameras, and an ultra-long battery life. Really is the goal behind this system, is to make it exceptional for the value, and also still useful.
Still
right?
professional.
Exactly. Still professional, still useful. Onto the LiGrip O2 Lite, which we released late last year. It's compact and powerful, real-time point cloud output, which is something that the SE does not actually support. And then also it's higher precision. So the IMU in the O2 Lite and the O2 is a higher level precision than that of the SE, as well as dual V-SLAM cameras, which the SE does not currently have. And that allows for that. That allows for that MLF SLAM. So a scenario adaptive algorithm, right? So what we talked about earlier, having all three of those inputs, the SLAM, the cameras for the visual SLAM, as well as the GNSS, allows for that multiple localization and fusion mapping that we've talked about before.
Yes.
onto the O2. So
Yes.
our flagship product that we have released
Yes.
just over the last 2 months,
Yes.
even more professional than the previous models.
Yes.
Its accuracy is an absolute accuracy of 3 centimeters, as we spoke about earlier, with a relative accuracy of 1 centimeter. More cameras than the O2 Lite, so actually 3 cameras plus the 2 visual SLAM cameras, so a total of 5 cameras, and the long range, right?
Yes,
So
yes.
with 3 different models, from the 120 meter 16 channel model
Yes.
up to the 300 meter 32 channel model. We have pretty much everything that you need, as well as that multiple, the MLF SLAM side of things. We can hit every market right there.
Yes,
right?
yes,
So
yes.
the LiGrip really does the job
Yeah.
that you're looking
Yes.
for.
So for the O2 product, we only released several months, 2 months.
Yep.
But we already received many good feedback about this product, about its reliable, its high quality, and its flexibility of the many accessories.
Exactly.
Yeah.
So being a successor to the H300, it had a big hill that it had to climb, right? Because
Yeah.
the H300 was a great device, but
Yes.
this system really just kind of blew the H300 out of the water at this point.
Yes.
So the full functionality of it, all in one system instead of a multiple, the battery and everything else.
Yes.
It is really, a fantastic system. Super excited about the O2.
Yeah. So now we have SE, we have O2 Lite, and we have O2. How should our customers choose?
Yeah, I mean, really it comes down to what they're looking for, right? So the performance comparison chart.
Yes.
Let me just change that mic. Is it on? Check. Yep. Real-time demos, guys. Real-time webinars. That's what.
Yeah.
But yeah, this is a really good chart here. So I mean, when a customer is looking to truly understand what they can get from the system, or which system they should get, this really does a detail of it, right? So we can see that the O2 really covers everything: multi-platform capability, horizontal and vertical accuracies, number of cameras.
Oh, sorry.
Oh snap! That's that rain level that
Sorry.
is getting us. Okay, hold on. Just
Can I
a
say
sec.
O2 can solve all problems?
I would say yes, except for the rain.
Yes.
That's
Exactly.
it's not going to prevent the rain, so
Sorry.
that's okay. Oh yeah.
Maybe. Yeah.
There we
that's
go.
good.
Okay, so again, all the O2 really does solve everything. But if you're really just looking for a cost-effective system, something that can produce Gaussian models
Yes.
at very easily with good battery life, then the
Yes.
SE, right?
Yeah,
So,
yeah.
but the O2 Lite is a cost-effective but also a beneficial product. I mean, it's limited in its range, right? So
Yes.
it's 40 to 70 meters max
Yes.
at that level of accuracy with multiple cameras. So you're getting that 3D Gaussian model.
Yes.
But really, it's just the perfect device. So where do you want to stand is really what it comes down to. What is the client's need is what's going to be the option or choice that they go
Yes.
with.
And you say if you just need some quick deliverable, and also you need 3D ghost result, you can choose our SE. But our O2 Lite and O2 has built-in high quality IMU
Exactly.
to and also have the VSNAM, so have real-time point cloud data, so it can help customer to finish the professional job, the work, the project.
Exactly. So just a couple more to add on that. So the absolute accuracy of the SE is around 5 centimeters. So that goes based on what you were talking about, that IMU.
Yeah.
The difference between the two of them, the IMUs really, stand apart. The range and distance is really the biggest factor between the SE and the O2 Lite versus the O2, right? So if you need 120 meter range, then O2 is the player. If you
Yes.
need even further than that, then the O2 32 channel 300 meter range is going to be the one that you go with.
Yes.
So there's several different reasons for what you're going to choose. One of the key factors though is that the O2 model is the only one that allows for all of our kits, right? So
Yes,
all of our
yes.
kits are capable with the O2,
Yes.
including the drone mounted kit, where the O2 Lite and the SE, they're limited on the drone mount kit, right? So they do not work with the drone mount kit. So
Yes. So we provide the SE. Oh yeah, another. So if customer still don't know how to choose the device, maybe we can have this real scenario
Exactly.
to help them to choose the device.
Exactly. So super simple to choose between. And in this case, I would say that in point density, the 3 different types of O2s that I spoke about, we're going to see the most coming from the XT32 and XT32M, which is the 300 meter, and then in tunnels, right? So either of them are going to be beneficial, but really when it comes to forestry, it's a high suggestion of the XT32 just because you're getting more density, more channels at 120 meter range.
Less noisy.
Yeah, less noisy, keeping things really tight and clean. So
Yes. So if you still don't know how to choose the device, you can scan the QR code and reach out to us, describe your project, and we can have the suggestion to you. And I see the dog is moving, so they notice we need to stop talking more.
Exactly.
Let's do the real world demonstration.
Exactly.
Yes. Let's go, Cody.
Sounds good.
Yeah. So maybe we can describe the dogs to our customer.
Come on, dog.
No, we need to stay here.
I know.
Yes.
Even the dog listened better than me,
Yeah.
so.
Yeah, maybe we can take a close look.
So as we can see, it is very raining, very much
Yeah.
so raining here. This
Yes.
is there's a lot, and the device, the rain is just bouncing off of it. It's fantastic. So
We have IP
Very-
16.4.
Yep, a very high IP rating that keeps it good. We still don't suggest collecting in the rain, right? Because of the fact that it's noise, right? So
Yes.
in the point cloud itself, there's going to be noise.
Yes.
So, but the device itself can handle this type of weather. I think
Yes.
it's doing better than I am right now in this weather. Like
Yes.
the rain is getting to me a little bit more than I was expecting.
If it's raining, I don't want to work.
Exactly. Don't even want to go outside, but the dog's like, yeah, I'll go anywhere at any time.
Yes.
So it's very cool though. So we have a system on this dog that is actually fully integrated. So it's not just let's put the system on top of the dog and power it from our own system. This one is actually being powered through the dog itself, and it has a 5G module on it.
Yes,
So
yes.
huge benefit there.
To
Huge
support
benefit.
real-time point cloud,
Yeah.
maybe we can see the
Real-time point
platform.
cloud upload, right? So
Yeah.
that 5G module that is built onto that device is actually able to
Yes.
upload a real-time point cloud directly over the 5G. So
Yes.
to a platform that we created ourselves, right?
Mm-hmm.
So let's see if we can pull this up.
Oh. Platform. Yes.
There we go.
Yeah.
So we have that real-time platform. Again,
Yes.
this was uploaded in real time. So while it's collecting, it's actually uploading data in real time. So as you can see, it is a sparse point cloud, right? Because it's real time, but it is a real-time reference point cloud, and it also has RGB. So we'll set that RGB on so we can see that RGB. We can also see the trajectory from it as well. So it's really, really awesome. I'm super excited about this. I think that it is the future of point clouds, right? Being able to quickly upload them via a 5G module or something like Starlink, right?
Yes, yes.
Being able to get data in the field. So
Yes.
if you're in the field, you're doing a demo, but you need to see something. Let's say it's forestry. So these trees here, we want to get those cut right away,
Yes.
right? So someone can
Yes.
be out in the field cutting the trees right as soon as they scan. So
Yes.
they can upload it. The guy back at the office guy or gal at the office can go ahead and look at these trees, do those measurements needed and say, okay, this tree meets the requirements for cutting. So go ahead and
Yes.
cut that tree, or go ahead and thin this tree, or do those
Yes.
thinning analysis in real time.
Yes. You
Super
can see
beneficial.
we invest many our efforts to help customers to do have less time to do the decision on site, so we can have our hardware smarter and help customers save our time to make quick decision, and we can provide more convenient reports deliverable to our customers. Also, the real-time point cloud can download
Exactly.
through the website.
Exactly. So we can download directly from their website and quickly do that.
Yes. So maybe also we can back to the device itself.
Yep.
Because I think our customers doesn't have many chance to see our mobile kit and backpack kit. Maybe we can have the real demonstration to our customers for
Okay.
the accessories.
Okay.
Yeah. Let's bring it to the demonstration site.
Oh. with the backpack kit? Or
Yes,
Okay.
backpack kit. It's too much rainy.
I think it's too rainy, yeah.
Yes.
I think in a situation like this, it's too rainy.
Yeah.
So we
So should we?
we won't do
clean
this,
up-
huh?
Should we clean up the device and then power on to see the app?
Yes, yeah. I think that we
yeah.
should first clean it first, though,
Yes.
and maybe pull it back here further. Yeah, there is definitely a little bit too much rain going on here. Again, that real world situation. Real world. But as a company, we still highly suggest do not be collecting in the rain
Yeah.
on a daily basis. That it's just that,
Even
that
you
noise factor.
are a robot dog.
Exactly. Even the robot dog, it's just that noise factor, right? So at the end of
Yes.
the day, the data is just not going to be that good if there's too much noise. So that's just the simple fact. But again, the devices can handle it. It's just the, making sure that you can actually use your data.
Yes. So I will power on.
Yep. And where's the director?
Oh, you mean the phone?
Yep.
Uh,
He's coming. He's here.
yeah.
Oh, yeah. I can just connect with mine.
Okay.
So we're just going to highlight here the device itself and the connection stages of the LiGrip. So this is the GreenValley app available via Android or iOS in the Play Store, in the App Store. On the user interface, we can see that we spoke earlier about the LiAir X4 Plus. We can see that's handled through this device, but also the LiGrip itself. So the original user of this GreenValley app. So if we're going to use RTK, which in this case we're not going to connect the RTK, but we can use RTK, which utilizes the hotspot from the phone, as well as the Wi-Fi to be able to get data directly from the phone to connect to RTK. But just for the uses of showing this on the demo, so we have the device that we can choose from, which is the LiGrip O2. So I would choose OK, and then we choose the Wi-Fi. So what's going to happen here is it pops up with the Wi-Fi. I'm going to come in here, wait for my Wi-Fi to pop up. We have the LiGrip O2. Pull that in. We got our, GreenValley password. And my hands didn't allow it. Oh. GreenValley. That's how cold I am right now. Not wanting to connect. So if you run into that, we can just press the button 3 times, have that Wi-Fi refresh.
Oh, because I think our staff collects the device.
Yep.
So
I think it's also my-
find if somebody collects your device, you can press the button 3 times, then reset the Wi-Fi setting, and then recollect the device.
I think my hands, I'm so cold that, yeah,
Is that okay?
nope, can't connect.
Yeah, let me check.
Let me refresh my Wi-Fi and then try it one more time.
Yeah, but I already have the Wi-Fi. It's your phone.
No, I can see the
What?
device. It's just not connecting to the device.
Yeah.
No. It's not connecting. Not connecting. I had to reset my Wi-Fi.
Yeah, it works.
So reset device Wi-Fi, which it shows if you need to do that, which we just did, and then connect device. So here we can see the power on self-tests. We can see the LiDAR is good, the camera is good, the GNSS is good, IMU, coder, and the remaining storage, 90 gigabytes, as well as a battery level of 71%. On the main page, we can see this device serial number, the battery level, device storage as mentioned. We can see the project management, which is the previous projects that have been collected on the device. So we can see a series of different projects here, all with their names. And if we were to click into a project, we can also see the sub-projects that are related to that. We can copy those projects directly either to a thumb drive or via cable. We have the activation status, the firmware status, and the equipment diagnosis. So if we come in here, we have the normal page, which is the collection management page. We can see the status of each of the parameters, as well as previous working status and previous jobs, as well as the RTK working status. If we go ahead and hit the play button, what it's going to do is pop up with the ability to create a new project. Here, we'll just call this Demo Day. Demo Day. Boom. And you can also choose custom coordinates. So there is coordinate system. So we have a series of different coordinates. It looks like this one was last used in Dubai. I think that was when I was out there for Geo World. And if we just do WGS 84, and then we could choose a zone, whatever we want, or I can just come back here and actually automatically click it. So then we'll just commit, do this demo day. We can name it, we can do a mission type, so the mission name. So you have a project from the day and then the several missions within that day. So say you want outside, inside. Name one of them as outside, one of them as inside, and we, as we mentioned earlier, that breakpoint continuation function. So the scene itself, we have outdoor. We can choose between outdoor, indoor, indoor, outdoor, or open area, which is that MLF slam that we talked about. So we'll choose outdoor. And then in this case, it is absolutely raining, so we'll choose rainy. And then we have the ability to choose the temperature, or we can choose the operator. So say Jim over there is the operator and he made a mistake. We can go to Jim that day and be like, hey, this day you made a mistake. You didn't do the right collection. Please go back and fix it. We can do the external temperature as well as the different equipments. So there's handheld, backpack, airborne, vehicle, and pole. We want to make sure we choose the right one when doing the collection. And then the real-time point cloud. So we can visualize a real-time point cloud on our app, as well as generate a real-time point cloud after the fact. So one that has been referenced, colorized right away in LAS format that can be pulled from the device, similar to what we just saw on the real-time web-based version. So in this case, we'll go ahead and do close just to save time. And then we have this choose picture. So we can just take a photo. We'll take a photo of that robot dog. Even though it's not the device that we're using, we'll still take a photo of it because it's cool. It'll save that photo as a metadata. We'll go ahead and start. From there, we'll see here at the top it says ready. It starts to say collection preparation. At about 15 seconds or so, the device starts to initiate the camera, and we start to see that the camera is going. Right now, the camera says idle, but soon we'll see that the camera says that it's recording. And in about 20 or 22 seconds, 25 seconds, the device starts to spin, and it's creating a base map. That base map is what the device is using as that point A that I had mentioned before. So at about 22 seconds exactly is when we got that base map. The device is spinning at about 25, 26 seconds, and now we're really getting this detailed results in real time. So as of now, it's really only seeing the tent that we are in, but the quality of that tent is quite amazing. But now we can see the trees, and so if we were to pick this up and just walk around with it briefly, we'll go ahead and see on the screen that the trajectory is going to start to change. So there's a red line with the trajectory. I can just walk around freely. I don't have to hold it, in a very specific way, but in a comfortable way for yourself. You can switch hands, make it easy for yourself. That's actually why we created that labor-saving backpack kit, to make it so where that the user can walk hands-free completely with the labor-saving either front pack or backpack kit. So super simple, easy to use, super user-friendly. The app makes everything super easy to use as well. But if I want to, instead of using the app, I'm going to go ahead and use that start-stop button on the back, just to highlight the ability to do manual operations. So at the same time, actually, I just hit a GCP, so I should have held it longer. But as we can see, it's collecting a GCP because I pushed the button once. We'll wait till that stops. Now I'll go ahead and hold it actually to get it to stop. So now it's fast rapid flashing. We can see that the device is saying stopped collection, data is being saved. It's at 44% already. So that, 1 minute scan is going to save in roughly about 1 minute or about 30, 40 seconds. That will get a data set. And then I'll just highlight real quick the real-time point cloud once that's fully saved.
Also, maybe we can describe the accessories.
Yes.
Yeah, because this is the first time we introduce the mobile kit to customers, right?
Yes, yes. So as soon as, yeah, so what we can do here is just show the level of detail that came from a 2-minute scan, right? So that is that entire park, the entire area that we're at. Oh, I got it upside down. Yep. That entire park, the entire area is done and scanned in a short amount of time. What I could do super cool about the app itself, I can measure, right? So say I want to know just the distance between this park and myself. I can drop these points here, confirm the area. The selected area range is too large, so we make it a little bit smaller. Confirm the area, set another area. Boom, boom, boom. Confirm the area, and now start the measuring distance, and we can see that the measured distance that I did was a clearance distance of 15, horizontal distance of 15, and a vertical distance of about 1, or 17 centimeters or so for that vertical distance. So super cool, easy functions that can be used inside the app. I can change the size of the points if it's too hard to see the points themselves. I can change it so it's easier to see. I can do a render mode, change it by height, change it by intensity, so I can see it in different views. There's a lot of cool things that we can do. We can drop the elevation of it so that if we want to see just the trunks of the trees, we can see just the trunks in real time.
It's very forestry applications.
Exactly. So many features that the app has. So now, yeah, we'll move back over here.
Yes.
So I'm going to turn off the device because it's not smart to disconnect the battery without turning off the device.
I will have another one.
So it's just a long click there to get it to turn off. Takes about 10 seconds or so for it to fully shut down after it does its self-checks. And then I'll go ahead and plug it in there, but we should probably wipe that before plugging in. So right before we plug it in, we'll go ahead and wipe it, just to prevent any type of
you mean
discharge. Yeah.
Okay.
So
Let me
wait till that we're no, yeah. Okay, so I'm going to just put this umbrella here. And so what we'll do here is highlight the simple use of disconnection. So one pull of the lever, push the button on the side. Now the device is disconnected. I can take this, easily slide
Please
it.
take a close look.
Easily slide it in and out of the system, lock it back into place, and now we have the way that the system is set up on the mobile kit. We take the battery from the handheld kit.
I think this is the main upgrade of the mobile kit, because our H300 series, we also have our backpack kit, mobile kit, but our auto mobile kit is very convenient to use.
Boom.
Yeah.
And now it's ready
It
to
works.
go.
2 steps. It
Two
works.
steps, and then I can go ahead and power this on. Now we have a device that is working on the mobile kit, and if the same thing, if I wanted to take it off of that, I can easily just slide it here onto this kit itself as well, which has the dual batteries. So we have dual batteries here, which is where we were talking about, depending on the device, anywhere between 4 to 5 hours of collection time, and can be hot swapped. So in the middle of a scan, pop that off, put on another one, and collect data continuously.
Yes. Also, the mobile kit is magnet.
Exactly. So our older version on the H300 had suction cups, which were not as reliable, depending on the type of vehicle that you had. These magnetic mounts make it a lot easier. You just lock it onto the car and it's ready to go. Do your scan. You can actually operate it from inside the vehicle as well, right? So not the driver.
Steps.
Exactly, yeah. Not the driver themselves, but the individual. So for safety reasons, you know, you have someone with you in the passenger seat to operate the device while driving. But it makes it super simple. So the mobile kit is a very, very useful tool. Does have limitations right on the speed. So speed
14 kilometers.
Exactly.
Per
so
hour.
40 kilometers an hour. We still don't suggest doing, 2-hour-long scans with it, right?
Yes, sure.
So maybe hour-long, half-hour-long scan, but we're talking big data when we're going those size. And then we also have the front pack kit. So the front pack just sits on the front, makes it so it's hands-free, and a phone mount as well that holds the phone. So you can just operate, touch it, walk around, walk freely. And then, so the beauty of both the front pack kit, the backpack kit, is the O2 SE
phone
and the phone.
Phone kit. Phone holder.
So the phone holder, super simple, ready to go.
Like this scenario, I have the umbrella on my hand, so I can do the
Exactly.
scan like this. It's very convenient.
Exactly.
Yes.
And it's also light too, you know, like
Yeah.
the
Hold single hand.
exactly.
Small woman.
Exactly.
Yeah.
Simple, easy to use. The LiGrip product lineup is fantastic. Like we've come a long
so
way.
maybe we can have a new function release, the cloud computing.
Yes.
Yes,
So
with our SE hardware.
exactly. So hopefully in the next month or a couple months or so,
Yes.
we'll release some major updates. So stay in tune and stay in touch to find out more about the Grip series and what
Yes.
we're capable of doing there. So
Yeah, we are searching for more scenarios for our customers, for our O2 customers, to search more scenario. Maybe we can support real-time data uploading to the
Exactly.
cloud, and then our cloud can process the data automatically for our
Exactly.
customer. So when you finish the collection, after 30 minutes, maybe you already have the result.
exactly.
Yeah, so finish the collection, back to the office, you can find, the result is on my computer.
Exactly.
Yes,
Already
yes.
ready to go, or someone back at the office can be doing it while you're still out there scanning, right?
Yes,
like
yes,
that would be
that's
the major
great.
benefit there is
Yeah.
that. So if you had questions, make sure that you reach out with the info at
Yes.
GreenValley email
Or scan the QR code.
or scan the QR code. Make
will
sure you
get
scan the
1
QR
year
code.
free electricity trial.
Yep.
Yes. Let's back to the table, and we it's your phone.
It is. Yes.
Don't forget it.
No worries.
Yeah, so when we finish the data collection, of course, we need to check the data quality. Yeah, that's paper.
Yeah.
Yeah.
Okay.
Yeah. Maybe we can show some AC data, Autolite data to customer.
Yes. So I think we'll start with the O2, the SE. So actually, this is. So we'll go ahead and start with that SE. Park result. So the beauty of the software itself, so right now I'm actually just highlighting the already processed side, right? So using MLS to create a new mapping project. So I first inputted in the point cloud itself, then I inputted in the trajectory file, and now I'm inputting the file that's related to the panoramic images for the device.
Yes. If you use our ML software BP module to process the data, in the BP module, you can one click to our post-process interface.
Exactly.
So no need to drop all the single files based on the creating project freeze.
Exactly, which I'll show that with the O2.
Yes.
So the the O2 data set.
Oh, you open the two.
The other one was already open, yeah.
Yeah.
But this was the SE, so this would be. I think
Maybe you
the
can.
rain is killing her. I'm gonna close some other files, but I think the rain is killing your laptop.
So I think our O2 has another solutions, another options about the high gain antenna.
Yes, yeah. So we do offer that high gain antenna for situations like very high buildings or areas where you might have multipath air.
Yes.
That high gain air antenna allows for higher precision in those environments.
Yeah, for the high gain antenna, I think it's suitable for some scenario like under bridge and near the closer to the buildings. So in this kind of scenario, we recommend the customers to choose high gain antenna to maintain the RTK signal qualities. Yeah, so when you have the high gain RTK, you will get more stable RTK signal qualities to ensure the data quality. Yeah, so maybe we can describe we can introduce the application cases to customers firstly.
Yep. While we're waiting on that, yeah. I think the Rain is playing with her computer.
Oh yeah, it's opening the software, and
nothing's-
maybe we can start with the application cases.
Yep.
And also, just now we introduced the robot dog applications. What kind of applications can it conduct? Emergency response,
Yes.
mining.
Yes. So
Yeah.
emergency response situations again where humans can go. So being able to send a robot in is much safer and viable than having a human going, right? So that the robot dog is a fantastic addition to your lineup of traditional products. So I'm very excited about that, as well as with that 5G module. The system is able to work, and the fact is there's a lot of these robot dogs on the market, right? There's
Yes.
tons of them on the market.
Yes.
We've worked with several different companies, but we
Yes.
can also work with new companies.
Yes,
So
yes.
that's the beauty of us, is that we work together and integrate very well.
Yes.
So as mentioned, that one's fully integrated and it was super simple. Working with them, we can make things happen. So.
Yeah, because I think we provide the general adapter to all companies, to all robot dog companies. I just said, I think GreenValley is always open to all the companies, our partners and our customers. So if our customers choose another another brand of the robot dog, but you can always choose our O2 Lite O2 series to adapt to your robot dog to do some emergency response applications. Also, we are deep integrate with the robot dog, not only simple mount on the dog, right? So we have our 4G module, our O2 Lite. Then we can have the real-time point cloud data through the website to do the on-site decision. Yeah, maybe we can have some guideline to the robot dog in the unknown space.
Exactly.
Yeah. Help to the dog to make decision about how to like our LiAir.
Exactly.
Yeah. Autonomous data collection. So maybe we can start with some our customers' use case.
Exactly. So, I mean, this one's just highlighting the real estate measurements, right?
Yes.
So, getting high quality measurements from an as-build, we can call it.
Yes.
Or let's say that you are going in and you're an interior designer and you need to be able to fully understand the inside of a space.
Yes.
And you want to get accurate measurements quickly without going with a tape measure or
Yeah.
a laser rangefinder.
Yes.
And just take the device in there, go back home, do the measurements there, and create your 3D model using the Revit plugin, right? And have that at home, right? Super simple, easy to use. So real estate measurements is one of those use cases. So,
Yes.
So advantages of using a handheld device for real
Yes.
estate measurements: no need to draw plans on site. Simply focus on data capture. 3D surveying approach with nothing missed. Irregular structures can be measured freely.
Yes.
Panoramic synchronized capture can also be used later to assess non-measurement information, ownership, and violations. And efficiency is 2 to 3 times higher than that of a distance meter. So
I think the estate measurement is very suitable for our SE device.
Exactly.
It's cheap and it's light and it can easy to use.
exactly. Yeah, so just continue highlighting that field scanning.
Also our software.
Exactly. So using MLS to extract, DXF files,
Yeah.
that auto vectorization that I talked about earlier for floor plans, DXF import into CAD is also a huge thing, and then that BIM modeling, right? So using Revit to do BIM modeling of as-builds is a huge benefit in the real estate world. So highlighting an as-built documentation. This was from one of our recent clients.
Yeah.
Super well done. The client did super well with this one.
Yes.
So the Ubasat Watt Machkram, I probably killed that. Well, I'm sorry, my Thai families out there. Has experienced material and structural deterioration due to long-term use and environmental exposure. So as a registered National Historical Monument, its conservation must ensure both structural safety and the preservation of historical and cultural significance. So using something like the GrIP, from outdoor to indoor, getting these scans done, they were able to create, this real-time as-built drawing that is just profound, right? So some of these buildings, could be hundreds of years old.
Yes.
They had no drawings back then, right?
Yes.
So bringing what was previously made a long time ago into modern age digital can save this in the future. Say a disaster or something was to happen to any, older buildings. Having these models makes it so that we can recreate them to the T, right? So God forbid an accident happens, but we can recreate them utilizing technology such as the LiGrip.
Yes. Also much thanks to our customers provide so excellent case to us.
Exactly.
Yeah. We always appreciate it.
Exactly. Yes.
Yeah.
And please, for any of those out there that have case studies that are excited to share with the world, please, reach out to us. Let us know. We would be more than happy to show those.
Real world case.
Exactly. We can only reach out so much. So if you have some, let us know. We'd be very happy to do so.
Yeah.
Yeah. And another scenario, bridge pier surveying, right? So the Zhujiang Bridge is located between Foshan and Jingming in the Guangdong province of China. And it expands the Zhejiang River, and it's a shopping corridor, and its main navigation channel of the Pearl River system, which is it's one of the busiest areas in the world, right? Like a lot of the world's lifeline comes from that region.
Yes.
A lot of manufacturing comes from that region. So making sure that it stays safe and that we are able to, keep humans moving across it, but also vessels moving across it, right? Is a big thing. So getting out there and doing these surveyings, getting very detailed results from that, getting out on a boat and actually, doing these scans with the O2 is also amazing, right? So doing these scans from a boat is crazy. It's 10 kilometers an hour on a vessel. Took 30 minutes, but an office processing time of 90 minutes. Not too bad for something that is as big as a bridge. And very few features, right? So this is a perfect example of the MLF slam and the featureless environments, right? Because although there's bridges, the water tends to potentially be an issue.
Feature.
Exactly. So being able to get details from that, we get things like this point cloud with precise horizontal and vertical alignment. They were able to go out and compare these with traditional drawings and see that the accuracies were as stated. So we're getting these high quality results.
This is what we say why we provide the high gain RTK Artino.
Yep.
Yeah, this is because we want to provide the high accuracy result to customers, so customers can choose. We provide so many accessories to our customers.
Exactly. And then so the 3D surveying of GOF. We spoke a little bit earlier about the GOF. That those areas within inside of mines where it's been extracted. So features or they have gotten what they needed from it, but they need to make sure that it's still secure and safe for people to go into. So utilizing the LiGrip with the drone kit, being able to get in there and do these scans is a huge benefit of a system that traditionally you would have had to walk through a potentially dangerous area, right? So being able to handle that now is the benefits of that drone kit. So it was a copper mine in Guangxi required the collection of a 3D data from the GOF, and the backfill volume needed to be calculated. So they were able to do this in 5 minutes in an processing time of 10 minutes, right?
Yes.
So an entire mine that they were able to potentially save future lives was done in 10 minutes. So super cool surveying. The created a mesh model, the mesh hole editing. So a lot of the times with mesh models, we can see that there's holes, right?
Yes.
And one of the benefits of LiDAR 360 MLS is editing that, right? So as well as in LiDAR 360 editing that. So
Yes.
that closed volume calculation that came from it is enough to be able to take to them and be like, okay, this is what we have, this is what you're looking at.
Yes, and one function didn't mentioned, but I want to highlight is the cross section in our LiDAR 360 MLS.
Yes, yes, being able to do the tunnel section or cross section analysis, right?
Yes.
And even differential periods, right? So you can do this
Two-phase data.
Exactly, two-phase comparisons, so that if there was issues that occurred, right? So say you scan this week and you scan in 2 months,
Yes.
you can run an analysis to see if there was any type of slipping or any type of changes that it
Yes.
may have changed, that it may have occurred to this mine. So it's super beneficial tools that LiDAR 360 MLS and LiDAR 360 are offering at this point.
Yes.
And now, with the side of Powerline and MLS,
Yes.
we're able to do distribution network inspections for route planning, right? So today, distribution network inspection is being increasingly automated with drone docks, as we showed earlier. The key lies in flight route planning, but compared with transmission lines, distribution networks are lower. It's not as common that you can get drones into areas where distribution networks are.
Yes, yes.
What we showed earlier is the middle of a field, right? So it's okay to do, but the distribution
Yes.
networks inside cities, most places you're not going to be able to actually get a drone there.
Yeah.
So having something like the LiGrip products allows you to get
And
there.
long range, short range, you can choose.
Exactly. You can get a lot done at one time. So those are some of the key advantages. The no airspace approval required, supports PPK for high precision positioning in areas without network coverage, and supports that dual battery backpack setup. So you can
Yes.
collect for up to 4 hours, if it's the SE even longer. So single operator deployment can do these types of things that traditionally may have been a whole team of weeks of work, getting done in a very short period of time with the O2 products.
Yes.
Still highlighting that field scanning to post-processing to Powerline flight path planning. So that's another benefit, right? So say it is an urban environment and the only way that they allow you to fly there is if you can validate a safe flight pattern, right?
Yes, yes.
So you could walk through with the LiGrip the first time around, walk
Yes.
through, get your data, pull it into Powerline and run a fine inspection route generation.
Yes.
With that fine inspection route generation, you can run a safety optimization, which
Yes.
determines how safe is the flight based on the specific parameters, 2 to 3 meters away from specific objects, which you can't do that if you just go up and show up and fly, right?
Yes.
If the requirements are from the city that it has to, you have to prove your safety before doing it, right?
Yes.
So coupled with Powerline and the LiGrip O2, you would be able to do these types of flight planning route generations early on and do amazing work in cities as well with the O2.
Yeah.
This one is a California yellow pine biomass survey. So forests are the largest carbon reservoirs in terrestrial ecosystems. They absorb carbon dioxide from the atmosphere and store it in vegetation or soil, playing a vital role in the global carbon sink and carbon cycle. Against the backdrop of global warming, countries around the world have set targets for managing carbon emissions and carbon sinks, including the Paris Agreement, the Kyoto Protocol, and China's dual carbon strategic goals. As a result, forest biomass surveys have also received a widespread global attention. So being able to take the requirements of the O2 Lite and target plot, the plot covers approximately 3.6 acres and consists of a single tree species, ponderosa pine. For this project, SE equipment was used for data acquisition and the LiDAR 360 was used for biomass calculations. So we can see we had an individual tree segmentation as well as the classification, and then ran
trunk,
exactly and ran the LiDAR 360 biomass calculation. And that is, hopefully maybe I can open up the software. So,
That's scary.
oh, the benefit and the beauty and fear of those dogs. It just took off on me next to me. That actually startled me. Okay.
Maybe I think he knows it's stop raining. He wants to work.
That's exactly. He's like, okay, it's time. I'm getting back
time
to work.
So let me summarize. I think LiGrip solves the core problem after entering the site, how to collect data efficiently and accurately and reliably, and turn it into deliverable. So combined with our software, it enables our complete workflow from collection to final output.
Exactly.
You
So
can
I'll
open
just
the data.
yeah. So I'll see if I can open the data. They were able to reload. There is no the raw side of it, so we'll just open up what we can open. There we go. Okay, yeah. So definitely was just a issue earlier with the computer needed to dry a little bit there. So
Because of the rain.
exactly. So yeah. So here we can see this is actually that same area that we did with the
LiAir A?
the LiAir A. Yeah.
Yeah.
So same exact area, but this was done with the SE. So really, it is the same sensor that we're seeing from that. It's the mid 360, but we're getting a bit more
detailed
crisp. Exactly. So
result
that
because I think the product position is different. One is for the dangerous space that people cannot enter, and then we can use our LiAir. Its advanced, intelligent, autonomous functions to collect data. But if you can enter the space, and if it's the natural forestry, you can use our O2 with high precision IMU and with high precision camera and laser to collect the data.
exactly. So yeah.
So you can see the details.
Exactly. Yeah. Much more details in that because of the processing, right, and that filtering side of things is cleaning it up a bit, and so yeah. So the SE, great product. For the cost effectiveness of the product is amazing.
We so-called cost effective, but still do very professional work.
Exactly. That's
what GreenValley always insists.
Exactly. So let's take a look at the O2 real quick. So same location actually that we're sitting right now. We'll add in that trajectory, and we'll add in those photos. And we'll hit OK, pull that into the mapping project. And now we can see there is definitely a detailed difference, between the results of the O2 and the SE. So the O2, there's more points, right? So more points, more density, so we can see that there's less gaps. The rotating head too, that makes a big difference on ground control, right?
Yes.
So if your main goal is creating terrain models, I would definitely suggest the O2 because it's able to produce a lot more points on the ground, so that terrain model is much better than that of the SE. So that's definitely something that customers should definitely factor in when they're doing these types of research and purchases for these systems. So let's go ahead and take a look at this side profile real quick. Let me adjust this buffer to 0.1. Yeah, and so now we got this, really, really tightly fit, beautiful ground surface that we're getting from that. Beautiful, beautiful data set. Very, very tight.
Zoom in.
Very, very nice. Very, very nice. Very nice. So yeah, this is again, I'm very impressed with the O2. The device itself is fantastic. And then if let's just see, we'll do one more. We'll add in that O2 Lite, what we have from the O2 Lite, just so that we can show, all three of these products. Wonderful products. Get over here, trajectory and camera.
So I can see the main difference between O2 Lite and O2 is the range.
Exactly, range, point density. So yeah, so this, you can see one more panoramic camera. So we can see, yeah, some difference here between the O2 and O2 Lite. Definitely not as dense. So we can see if we zoom in, the RGB looks good, but we got the spacing, right? So a bit of spacing, but still totally usable for terrain modeling. Really, really good. So all three of those are fantastic, fantastic examples. And one of those things that we're seeing right now is that blue sky effect. So it's one of the benefits of the software, right? So if we wanted to make the processing or to make it look better, we can run the optimized sky color points. Because when you got beautiful blue skies, you get this blue effect across the board in all industries. But we have tools in our software to mitigate it as much as possible. So we can run a tool in the pre-processing side to make it so where that it'll actually colorize those in the green color that they should be. But it takes longer, right? The benefit of our software is we have very fast processing.
Yes.
If you want it just bare and easy without filtering, you
Yes.
can do it one-to-one almost, you know.
Yes.
The 10-minute scan could take 10 minutes to process. But if you want it super detailed, like the high density mode, right? So we
Yes.
have a high density mode that can
Maybe
add
we
points.
can back to the BP module interface.
I don't have any, I don't think there's any data in here. For
Raw data?
yeah, there's no
Yeah,
raw data.
because I want to highlight our logic design for the workflow.
But there's
we
no-
provide the one-click workflow for the data process, and otherwise we also provide the advanced parameter settings functions to customer. So this,
But I don't think there's any raw data.
okay.
We have no.
Yeah, no, I think this interface is enough.
Okay.
Yeah,
Yeah.
you
okay,
can
okay.
see the one-click workflow.
Yep.
Yes,
So
the logic, so-called our customer called logic design, but we of course we provide the one-click workflow and logic design, but we also provide some parameter settings for customer. So the process no longer how to say blank box to customer. If customers want to adjust the data and more advanced settings, we provide the setting interface to customers. They can have the choice to change the settings.
exactly, and as you had mentioned, the one-click touch to open up in MLS would
Convert
be
to
just this
mapping project.
convert to mapping project. Some of the tools that we talked about earlier, the base map, being able to have a base map, converting to ASCII. We have the display settings. One of the features that I didn't mention earlier, so is this concept of the built-in chatbot that we have, the AI chat
Yes.
Chat tool where you
If
can
you
ask it questions.
If you don't
and-
know how to perform the classification, how to perform the flow plan, you can click our AI assistant to ask how to use flow plan function
Exactly.
module. Yeah.
So pretty much like a built-in tech support, right? In a way,
Yeah.
it gives you some help. And another benefit of the LiDAR 360 MLS and LiDAR 360, just while we're on the topic, is this model builder, right? So we
Yes.
have this
We
new
can
model
create
builder.
ourselves workflow.
Exactly. So we can either use GVI's pre-existing models. So we do have
Yeah,
some
we already
pre-existing
provide
models.
some workflow for customers.
Exactly. Or you can come over here, and if you want to add a feature to this, let's just say the segmentation side, I want to do like a seed editor or DBH and height, right? I can drop in a tool directly in here, and then it's now added in there. So now I can adjust the settings of this DBH and height tool that we're getting from here, add it to that, and run the model. So
Yes.
it's a super beneficial tool that I think that we needed for a long time, and
Yes.
we got with that version 9, and I'm super excited about that as well. I think it's very beneficial.
Also,
and
we
useful.
support both our pre-process and post-process for the cluster computing.
Exactly.
Yeah, because our O2 will always sometimes our O2 conduct a large-scale project, and then the data process will time-consuming. This is why we provide the cluster computing to customer, and also we can conduct the pre-process under the cluster computing.
Exactly.
This is very important for our customers, not
Exactly.
only the post-process.
Exactly.
Yeah,
So,
so
I
I think,
think
that's
we-
all from the LiGrip part. And if you are interested in our LiGrip series, and if you have more problems or more demo requirements from us, please scan the QR code and reach out to us, and we can provide some one-by-one suggestions to you. Yeah, we can say this is the big guy.
Yep.
LiMobile.
That is the big guy.
Yes. So just now we walked through a complete workflow from understanding space to actually operating with it. Now we can shift perspective again. In many real projects, there's another critical requirements: large scale, continuous, and high efficiency data collection. For example, city road data collection, highway inspection, and pipelines and railway projects. These are long-distance scenarios, and this is exactly where mobile mapping comes in. So let's move to our LiMobile. Cody, please walk us through what is the system designed to solve.
Absolutely. So as you mentioned, large scale mapping.
Yes,
right?
large scale.
Large scale mapping.
Highway.
Exactly. Highways, I mean, city to cities, like we're talking large scale mapping. Something
Yes,
that the grip is amazing, but it can handle 300 kilometers worth of scanning, right?
Yes,
Like that's just not going to happen. So that's when you need something like the LiMobile M2 product line.
Also the camera.
Exactly. The camera, the high resolution that you're getting from either a 32 or a 30 megapixel camera up to a 72 megapixel camera is a big deal. So, and then being able to have those high quality systems, right? So the single line beam is looking at millimeter, right? So we're talking, before all the systems that we were talking about before, we're talking about centimeter level, right? Which even the Hesai based sensor that we have there is still centimeter based.
Yes.
But we're happy to introduce a few new products, right? So
Our latest product.
the
M2
latest
Pro.
product, yes, which is our M2 Pro. So out of the M2 series, we have the M2, which we consider to be, in this case, a basic model. It's got two Hesai XT32 M2Xs on there, one for SLAM calculations and one for survey calculations, as well as the Ladybug 5 Plus. Then we have our LiMobile M2 Pro, which is the latest release, which also has a single line beam. The sensor was a collaborative design, so it's really comparing to that of a Regal-based sensor, but much more cost-effective, right?
Yes.
And then the LiMobile M2 Ultra, which is the system with a Regal-based sensor. So we know that some may need that high-level response from a Regal-based sensor, so we do have our M2 Ultra as an option as well.
Yes. So we can walk through the LiDAR specifications for these three models.
Exactly. So the one that you see here on the table is the M2. It's got a point rate of about 1.2 million points per second, a range of around 300 meters, with a relative accuracy of 2 centimeters and an absolute accuracy of around 5 centimeters. Where we move up to our LiMobile M2 Pro, we're talking about a pulse rate of 1,000 kilohertz, a range of 300 meters, and a relative accuracy of 3 millimeters. So that's where we're getting the difference between the XT systems and the Pro system, is that we're seeing a relative accuracy of 3 millimeters and an absolute accuracy of 3 centimeters. So it is much greater in the point cloud thickness than that of something like the XT systems that we get from the M2 Pro. So if you're trying to do like high accurate pavement analysis with the LiDAR
detection.
Exactly. You to run an IRI or a PCI, you need that millimeter. Like that's you need to see those differences. So something like the M2 Pro is going to be able to provide that, as well as something like the M2 Ultra, right? So a kilohertz rate of 1800, so even more points at a higher frequency with a range of 475 meters. So if you need to push it out, into distances, the relative accuracy is still 3 millimeters and the absolute accuracy is still 3 centimeters, because the IMUs are the same in these two systems, right?
Yes.
So at the end of the day, the system itself, it really just comes down to, what do you need from the point cloud? Do you need that thickness? Do you need the thinness? It really just depends on what you need from those that you would be paying more or less for between our M2 products.
Yes. So besides point cloud, I think image is also critical.
Absolutely. So all three of our systems provide a series of different camera options, right? So we can offer the Ladybug 5 Plus as an option, which is 30 megapixel, frame rates of 10 frames per second, and it can offer a trigger mode of time or distance, where the latest advent or release of our M2 Pro, we also added in the GS2, which is a 72 megapixel camera, 5 frames per second, as well as a trigger time or time or distance trigger rate. And then the Ladybug 6 Plus. Everybody knows the Ladybug 6 Plus offers 72 megapixels, 5 frames per second, as well as the same trigger mode, time or distance.
Yeah, so what's the difference between time trigger and distance trigger?
Yeah, so I mean, I'm glad you asked that. So time trigger would be a situation where it's constantly triggering over time, right? So there's specific time factors that come into play. Where distance is, let's think about a scenario where you're at a stoplight, right? And at the stoplight, you're just continuously taking photos, like over and over and over and over of the same spot. So it's just taking up data, taking up storage space, which it's unnecessary because it's just repeatable. So a distance trigger is when the car is actually moving, but it does require our DMI.
Yes.
distance measurement indicator,
Yes.
to know that the car is actually moving,
Yeah,
right? In
yeah,
this
yeah.
case, to tell it, okay, fire now, fire now, fire now, trigger now, trigger now. So,
Okay.
so yeah, so key differences.
So if you need the distance trigger, you need to buy our accessories, DMI.
Exactly. And honestly, we would suggest the DMI just because it's beneficial, right? Like,
Yeah, because of the tunnel scenario.
exactly.
Yeah.
GNSS, the night
Night.
environments, SLAM can do amazing things, but
Yes.
adding the DMI to it, you're really just getting that total package. It's not expensive. It saves you trouble later. It
Yes.
saves data. It's super beneficial to get the DMI.
Yes.
We also offer a planner camera, right?
Yes.
So we can have a dual mounted planner camera with that's 5 frames per second per camera, 24 megapixels in total because there's two 12 megapixel cameras, and also offers time and distance triggering.
Yeah, we already have panoramic camera, but why we still need player camera?
Oh, that definitely is a good question.
Yeah.
I mean, the pavement camera, for instance, right? So
Yes.
being able to have the camera facing directly down at the pavement at all times, its only focus is the pavement. So what we talked about earlier about pavement analysis. So our software is able to do automatic pavement detection. So
Yeah.
stresses such as like cracks and rutting,
Yes, yes.
much easier to be done from the planner camera that's only focused on that, right?
Yes,
So
yes.
if you're just focused on those, just run the planner data through that instead of
Yes.
running all the panoramic camera. Yeah,
So it depends on the project requirements.
Exactly.
If the project cares the pavement much, so you need to purchase the player camera.
exactly. As well as the front-facing one for detecting signs.
Facilities.
And, yeah, facility marking.
Because
And
our software can extract the facilities based on the image automatically and refresh to the point cloud and to see the vectors.
exactly. So yeah, just to highlight the multiple configurations that we talked about, planner cameras for pavements and for front facing, the 3 different camera options. So the GS2, Ladybug 6, the Ladybug 5 Plus, the Ladybug 6 and the GS2, both 72 megapixels, right? Just cost difference is where we're gonna see it. And then the DMI that provides that additional backing when there is the potential of GNSS denied environments.
So no, I think we can back to the last page. You mean the sensors can be configured freely too?
Yeah, so I mean, as long as when the client goes to purchase them,
Yes.
they say that, yeah, I want the M2 with the 6. That's a possibility. If they want the M2 Pro with the 6,
Ladybug 6.
they could do that. Or if they want the Ladybug or the Ultra with the GS2, they can do that. Or if they want the M2 with the
That's
GS2,
the-
they
yeah.
can do that as well. So
Yes.
it really just comes down to what they're looking for and what they need. We're willing to work with them and make it happen. It is flexible,
Yeah,
we should
flexible. Yeah, so I think this is also the first time we officially introduce a new camera to customers. I see it can be compared with a system like Ladybug 6. So what's the main advantage?
Yeah, I mean, I would say the main advantage is, so as we're seeing here, the Ladybug 5 Plus to the Ladybug 6.
Yeah.
Quality is great
Yes.
between both of them, but we can still see some blurring effects that may occur on the Ladybug systems. Some of the quality at times may not be as useful for the AI-based world, right? You need
Yes.
that high quality. So the GS2 really does provide this like high level of results and detail at a reduction of a price, right? So the overall cheaper price is majorly beneficial since you're still getting those high megapixels, right? So on the left-hand side, compared to the right-hand side, we have our we have the GS2 on the left and the Ladybug 6 on the right. We can clearly see the detail difference between the two of them. The Ladybug 6 still has great detail, but the lighting, the overall details that we're seeing from the signs, from the manholes, it's a big difference. So
Yes.
big difference.
We are not going to provide a cheaper but low quality product. Instead, we will provide a cheaper but higher quality product.
Exactly. So just some of the key details about the M2 Pro is that it's a single line sensor, as mentioned before, a range of around 300 meters, 72 megapixels, 5 frames per second, global exposure, And then the max supported 1,000 hertz frames per second, where the 600 hertz from the Ultra that we would be seeing. So,
so this is the page. I think this page is very clear for the accessory installation and for our data quality, the image quality.
Exactly. So as you can see, this would be exactly what we're going to see, in the real world.
Yes.
We have our base mount that is provided with the system. It does have a pull-out drawer that makes it so that you can pull it out further if need be. So if your vehicle's roof rack system is further up on the car, you can pull it out. But we highlight that there's the pavement cameras, the wheel speed encoder, so DMI, the battery box itself. So internal battery also supports hot swapping, the internal battery, which is great, and we provide 6 batteries, 6 B60 batteries with it. And the system itself, as mentioned, has a SLAM LiDAR on top for those GNSS denied environments as well. Like, let's say, an underground parking garage. That SLAM will be able to process for you there, where a traditional mobile-based system is not going to work in a situation like that.
Yes.
So having that SLAM is super beneficial, and then adding that 72 megapixel camera really just gives an overall package to the LiMobile M2 series.
Yes. So how just now we see the city road. So how about the you are introduce the installation?
That was yep. So just to follow up on your question, which was the quick release, easy installation,
challenging environment.
Yep. So again, highly integrated, flexible.
This one is the points I also want to highlight.
Yes. So the base system itself has the ability to switch its angle, right? So if you need to put it 45 degrees in one direction or 45 degrees in the other, people might ask, why would that be beneficial?
Yeah.
Well, for right away, right? So say you're on a road where you have steep embankments on the sides, right? And if the system is directly behind it, it may miss those steep embankments. So being able to curve it out a little bit puts the sensor out further, and it may get better results from those types of embankments. And it can go 45 degrees in either direction, and can adjust at 15, 30, and 45. So, and then again, long-lasting battery power, so continuous operation. We also support the external battery, which would be like the external power supply. You can switch freely. We provide the adapter for that as well. So the
adapter is free?
Yes,
Standard
the adapter
package.
The adapter comes with the package. So if you want to run, say you want to run the battery, the batteries that we provide, and then you want to continue collecting that day, you don't want to recharge, but you have like a external power source, just switch it over and use the external power source. So technically, you can scan forever, right? At this point, you can scan forever with this with this system.
But nobody can want to work forever.
Exactly, and I mean LiDAR works at nighttime, but why? Why? Go home, go home and rest, right? Now to your question.
That's my question.
Now to your question.
Just say city road, but we always encounter some challenging environment.
Exactly. So definitely underground garages, like we had talked about, areas with dense trees, right?
Yes.
So traditionally, a lot of mobile-based scanners would fail in areas where there was high tree coverage.
Yes.
So adding a SLAM scanner to that really just is a powerhouse. And inside our software, you can choose to process just a small bit of the SLAM. So say it's only a small bit of the entire scan that had these trees. You can use the trajectory that we provide. So you get your trajectory. It's color-coded based on the quality of satellites. So the actual coverage quality is highlighted in MLS, and you can choose just to reprocess that small part with SLAM. So it's a super beneficial factor to have. Very, very key.
Yeah. I think it's our main strength of GreenValley is the algorithm. So we upgrade the SLAM algorithm to support of all our device, all of the 4 scenarios, including tunnels, urban canals, and we also support our DMI integrated and post-processing optimization using control points to improve trajectory accuracy.
Exactly. So the total package, GNSS denied environments can be solved by SLAM, DMI, and a high quality software to do the processing. So
So what's the main difference between the SLAM and the DMI? What kind of scenarios I need to choose SLAM and another scenario I need to choose DMI?
Well, I mean,
Or about the feature?
It is, really about the features. So say it's a tunnel with 0 features.
Yes.
Obviously, SLAM's not going to work very well.
Yes.
It's going to have a hard time because it doesn't have those features to grab on. That's when you'd want to use a DMI.
Yes.
But if it's a tunnel that has a lot of distinct features throughout the entirety of it, then SLAM may work well. An underground parking garage is a perfect example for the SLAM, right? So there's lots of pillars and lots of features that are within the area of the SLAM that's going to allow for a better processing, where the DMI definitely is going to work best in situations where it is fully GNSS denied, but it is only for a certain amount of time, right?
Yes.
So tunnels is the perfect example where DMIs will work the best in.
Yes. And I see we have some new functions in our app.
Exactly. So some of the key functions that we've added is the real-time point cloud and image preview. So you can real-time view the planner camera, the panoramic cameras, as well as the point cloud. Both the SLAM point cloud as well as the point cloud as well. Though a guided operation too, so a workflow guided operation has been added. So you can, inside of the app, say you're working and you forgot how do I do this?
Yes.
There's now a workflow guided operation built into the app that you can just click. There's videos, it shows you how to do it. Real-time preview of calculated trajectory, which is awesome. You can see exactly what you've done before, so it's just pretty much a replay of what you've done. And then real-time equipment status monitoring, so knowing the status of the system, the quality of the system is all embedded into that.
And I know we also have a function voicer.
Yeah, so the voice thing is amazing because it's a voice prompt that pretty much lets you know, or the driver know.
Yes.
That
It's very practical functions because we can have one person to finish the collection work.
Exactly. So the system, even though it's relatively large and it goes on a car, one person
Yes.
can get the job done. One person can scan 20 kilometers by themselves and
Yes.
do it safely because there's
Yes.
indicators. They don't need to constantly look over at the app while it's going on.
Yes.
They just drive, right?
Yes.
Just drive, collect the data, and follow the voice prompts.
Yes, yes. So this is go beyond the hardware. We have our end-to-end solutions to customers.
Exactly. So one-stop data processing to deliver industry-ready results. As we mentioned before, all of it's done pretty much inside of LiDAR 360 MLS. You can do the pre-processing with inside of the MLS Geo module, all the way to the feature extraction to the sharing capabilities with LiShare.
So maybe we can move to the live demo.
Exactly. So just one, quick thing about the demo and the collection phases. We always still suggest collecting GCPs. It is only more beneficial for yourself so that you don't have to go back out in case something does go wrong, right? A situation where it's cloudy and the DMI only worked for a certain amount of time or something happened, Having those GCPs as a backup is super beneficial, and making sure you put those GCPs in areas where it matters. So before and after tunnels, open sky is less important, but still, good to have one every once in a while. And then limited sky visibility definitely is a good place to have those GCPs. So putting them out, choosing target point layouts, we tend to suggest using road markings. So whether it's a turn lane or the crosswalk edges, those are the best place for that. And then also route planning. So making sure that you accurately and correctly plan your route so that you know what you're doing. And you can also load in KML. KML file into the app, so you can follow that KML.
Follow the KML.
So knowing that route is beneficial, and
Yes.
having that KML is also very beneficial. So
Yeah, so maybe we can move to the live demo.
exactly.
Yes, let's go. I think maybe we have many vehicles in real world. So what kind of vehicles are recommended for the installation?
Yeah, I mean, we typically suggest SUVs. They're just it's the perfect fit for them, and many of them already come with the setup for the roof racks, so the crossbars. But really, any vehicle at this point, if it has the ability to have the mount system, we've mounted them on rail trucks. We've mounted them on all kinds of things. So, yeah.
so we can introduce the installation.
Yep. So here's the system as a whole. We have our roof rack system, which we had mentioned earlier. It's designed to fit onto your basic roof rack system. It can be universal. It has the drawer pull out, which I had mentioned, but it's already pulled out for this case. And we also have these mounting legs or pegs that keep it from bouncing up and down. They are suction cup based, so they can just sit on the top of it. And then we have the system where it just slides on. So we'll have our partner here go ahead and slide it on. Push it in there. It's actually if you can't see it there, it's a triangle based setup that the device slides into it. So it fits and locks in tight, and then just 2 pops, boom, it's now locked in place, and we have this locking mechanism. Twist it and it is good to go. So now the system is locked. For extra security, if you feel it's necessary, you can also use an Allen wrench to go ahead and tighten it even further. Say you're going to leave it on there for an extended period of time, you can utilize it that way. On the sides, we have these locking nuts. This is how we're able to turn it. So if we want to twist the device like we showed to 45 degrees, we just unscrew these nuts on both sides, twist it, and then lock them back into place, and then you can scan with that.
Yeah, also our player camera.
Exactly. So we have our pavement-facing planner camera, just locks into place. We put in 2 screws. The camera is now facing downwards. The 2 cameras, we have one facing this way, one facing that way. Both of them perfectly set up for pavement detection. The camera is plugged in on the side. So on the other side of the device, there's 4 ports that allow for up to 8 cameras. We have the front-facing, the back-facing, and that can be plugged in on the side over there.
Yes.
Up here we can see that there is the 2 slots for the drives. So one individual 2 terabyte drive for the panoramic side, and 2 terabyte drive for the system side. The panoramic is by far the largest files that come from it. So it's good to have its own protected drive, so that if anything happens or if it needs extra space, it's in its own drive.
Yes.
As well as the GNSS antenna that's on top of it. That is how we are able to do our PPK processing that's built onto the top of the device for all 3 of the versions that we have. The battery pack that we had talked about before is offering 6 batteries with 2 plugs, one for the DC out, which is going to the device itself, to the battery, and then one for the LAN from the device to the battery box. The battery box is also a push-through, push-out. So it's pushing out the Wi-Fi signal for the device, so for you to connect for the app itself.
Yeah, also we support dual antenna. So we also support a bigger antenna.
Yes, which can be mounted on the front of the rack system.
Yeah. So if you are in your area, the RTK conditions is not very good, so you can choose the bigger antenna.
Exactly.
So the system is big, but I think the installation is very easy.
Exactly. As you saw,
Single person.
Single person. I mean, he almost even looked like he could do it by himself with one hand. Yeah. It does have that handle. We get a little heavier with the M2 Pro and the M2 Ultra, but still a single person can do it. Still always follow safety work-related, lifting and exposure-based.
Yes. It's okay. Okay. Then we can power on.
And so over here,
the indicator, we can see the indicator.
So we see a green light there, and all he did is, which I should have highlighted on the battery box, is he twists the knob, and it's powered on, right? So he just turned it on. It's a simple twist knob, where our previous versions, M1, you had to turn on every single one of those batteries, and that was a little bit time consuming. But as we had mentioned, it's hot swappable, and it's slowly draining from each of the batteries, so that's why we're able to get this long battery length. And then we have the app here. So the provided tablet allows for us to open up the GreenValley app. From there, we can actually see that the device is not connected yet, so we'll wait a second because it'll automatically connect to the Wi-Fi. And that would be here on the device connected side. So it takes just a couple seconds or I would say less than a minute or so for the Wi-Fi to generate and the system to do its self-check, because it really does have a computer built into it. So As you heard the voice prompt, it said device connected successfully. We can see LiMobile M2. We can see the PDOT values and 0 satellites because we haven't started anything, and it's also completely gray out right now. But the system's about 20 degrees, which is the board on like in the system. And now we can actually see, yeah, there we go. So a PDOT value of 4.7 because of the satellites, but there is 35 satellites that we're seeing. We can see green indicators across the board: planar, panorama, LiDAR, GNSS. Down here, we can see that this is that preview window that I was talking about. So right now we can see the planar camera. If I was to come over here and put my hand here, it may take a second for it to register.
Here.
Oh, that's the wrong one. Yep. Slight delay there, no worries. We'll do the same for the pano. Oh, okay.
Also can see the real-time phone call.
Exactly. So, yep, there's the real time. It's just taking a second. Everything's getting delayed here. That's okay. Just doing those self checks. So here we can see, if we pull up this, we have the real-time point cloud. So the circular one that we see here is actually from the SLAM camera, the SLAM LiDAR. And then this really detailed one here is actually the survey camera. So we can tell by the tilt and the degree and the angle of it. And now that it's all loaded, we can see there is 6 different frames here from the Ladybug 6. There we are here. And then we also have that planar camera that we were showing earlier. So 2 different ones. There we go. So there was an update of him there moving. So there we go. So the system's really great. The ability to see everything in real time is really what matters. So there he is. It's just a slight delay there. No worries. And then in terms of the system, we have a base map, so we can do an offload map. So if you don't have cell signal or an area that you can do it, you can actually choose a map with using Wi-Fi first, then download it to the device and use that as an offline map. We can utilize and see the previous tracks that we've done. So if there's a track that you want to see, we can actually see that in real time. So I think that this one is actually from where we're at now. So if I turn this off, yeah, so yep, so we can see this track from what we did yesterday, which is going to be the same scan that he's going to go ahead and do today, which is through this little tiny forest here, but we can see those previous tracks. We have settings that we can adjust the settings for these, so navigation if we're using DMI, the offsets, the panoramic camera settings as well. We can change the intervals. This is where we can change between time and distance, as well as the planner. Yep, and DMI is connected, so oh yeah, so enable DMI, and then from there, we now have the option for by distance. So if we have by distance or by time, we can adjust that there. But again, is only...
This is really key, important in the notes. We need to enable DMI.
Exactly. So yeah, enable the DMI first, and we can actually choose which side the DMI is on as well. So that's another added feature compared to our previous versions. And then we have our log, which just indicates what the system status is at. And then this, which is that quick start guide that I was talking about. So there's links and videos that pop up directly inside of the device itself to walk you through these easy steps. So, and then, you know, the base map that we have the layers as normal. We can reset our target just like it would be on any other mapping system. And we can see
to the KML file.
Exactly, upload the KML file, recenter ourselves. So pretty much everything needed to do a survey safely. As well as the indicators that are at the bottom showing the data storage, so how much data we have left, the IMU status, the GNSS, the DMI, the tilted LiDAR, SLAM LiDAR, panorama. We can see all the details of that, as well as our speed. So knowing our speed is also very important. So
yes.
So we'll go ahead and hit the start button, which is this button here. It asks us to create a project, so we'll go ahead and call this test, as we are losing some light here. Okay. There might be already one named test. I think the one I did yesterday, but. So it's creating that new project.
maybe we need to refresh. We need to open the app.
IT 101, huh?
Yes. Also, I think we have many parameters here. And does we have any speed limitation?
Yeah, so the overall speed limitation of the M2 is about 80 kilometers an hour. With the DMI, it's suggested it can also reach up to 80 kilometers an hour. But the reality is between the sensors, there's differences in how fast you should go. So if it's purely for highway purposes, we would probably suggest the M2. It's going to be a little bit better.
So
let me give this to him for a second.
Does this DMI installation depends on the vehicle?
It depends on the lug nuts, so it depends on the actual tire itself, the rim itself. So
if customers need to buy DMI, they need to provide the parameters of the wheel.
Exactly. So we ask for specific measurements of the lug nuts, which we can provide a document that will help you do that measurement.
Yes. So maybe we can create the project.
Yep. So he went ahead and created the project. It's just Cody that makes things not work. But yeah, so what happened first there was created a project. The very first thing that we're doing is a static initialization. So the device is going to sit there for 3 minutes. Well, the vehicle sit there for 3 minutes without moving. That allows it to capture as much GNSS coverage as possible. Oh, it's snowing. GNSS coverage as possible, as well as creating that first initial base map that it's going to use. From there, we will utilize a dynamic calibration. So he'll do specific route planning, which we'll generate here. For the case of time, I'm just going to hit OK to skip past this because we don't have much time left. So insufficient time for it. So we'll go ahead and proceed now.
Yeah, proceed now.
Please ensure that the EMU system.
And this is a
Really clear
very,
instructions.
very detailed. This is even more so than it was before, which is amazing. So traditionally, we just said, drive this pattern. But now you have very, very detailed step-by-step guide of what you should do to receive the best result from the dynamic calibration. So he will go and do those drives. He'll go and collect the data. So we'll hit OK. So now that we've done this whole steps of getting the initialization and the calibration, we'll go ahead and hit play. And that play is going to start the triggering and firing. Yep, so that was that voice prompt saying successful starting of recording, which we can see here as well. All have got the green. New project was started successfully. Everything is going. So we have what we need, the LiDAR, the planner, panorama, and now we are ready to get out there and start the collection.
Yes. We can start the collection.
And he can start the collection. And for the sake of time, while he is doing that collection, we'll head back and take a look at the
data.
Exactly.
But I think it's gonna dark here, so maybe we can jump to the LiProtect part, go through the slides quickly, and then show the LiProtect demonstration first, because I think LiProtect product is a totally new product lines to customers.
Exactly.
Yes, and if we have time, we can come back to the LiMobile data. If we don't have enough time, we can share the data set to our customers.
Okay, yes. Yeah, it's a great data set. It's got some tree segmentation, individual tree segmentation that looks really, really good. So
yes, maybe we can go to the LiProtect slides first.
Yep.
Yeah, I think LiProtect is a new product now. Oh, yeah. Okay.
One. Same, both of us.
Oh, okay. So I think in real world there are another requirements that the previous systems cannot fully address. That is a continuous monitoring. So it's no longer about collection data once, but about continuous and reliably understanding what is happening in a space over time. For example, stockpile changes, power line safety, construction risk, and versatile docking. So these scenarios requires real-time awareness and continuous alerts. So the next product represents the final piece of GreenValley's spatial intelligence system, LiProtect.
Exactly. Super excited about this product. It's been in the workings for quite some time. So now that it's officially ready, which we have here, which is the LiProtect system, it's the final section of the data collection and application, right? So providing sustainable and stable data, solutions and services. Fully integrated, intelligent platform, easy to operate, real-time response, real-time notifications and monitoring, and high precision ranging. So the system itself, in appearance, the introduction, just real quick, is multi-mode communication. So it can or wireless communications or wired communications to upload data. It has a built-in AI processor for real-time dynamic monitoring, multiple interface design, whether it be Type-C, LAN, TF card. It's IP66 rating, dustproof, waterproof, as well as high definition camera. So 8 megapixel cameras allows for video stream transmission in real time, as well as a survey grade LiDAR. 450 meter range at 240,000 points per second. So the LiProtect working logic, real-time perception intelligence analysis. So utilizing 4G as well as connections, we get real-time rendering as well as front-end monitoring and on-site alarms from the system. So some of the beauties of this product is the multiple use case or the multiple setup scenario behind it.
So we provide different modes.
Exactly. So different modes, different setups. So we can use tripod base. We can.
Maybe you need to have this on your clothes. Yeah, to listen to this.
So we provide several different modes, as you had mentioned, and one of those would be either battery installation via a solar panel, or the provided battery on top of a tripod, or a fixed power source. So, and then using that power source via 4G to be able to transmit out from anywhere, right? So you can have this set up in the middle of nowhere, actively tracking or monitoring a situation, and be at home in the nice warm comfort of what I'm thinking about right now, where I want to be, tracking the background monitoring, right? So,
So this system relies on the solar charging, storage, and the internal battery, so allow it to operate continuously without manually intervention.
Exactly. And especially, I
think customers choose the modes based on the scenario, because it's if the towers need a long-term monitoring, so it needs the solar panel.
Exactly.
Yeah.
Exactly. Solar panel would be useful in many situations, right? If you can't get to it, right? Like you said, too high up, can't get a human up there to change the battery. Cables, you're in the middle of nowhere, it's not going to work. So.
Yes. And another mode.
And the other mode is that tripod-based mode, right?
Yes.
So we provide a tripod with a battery. This mode's more designed for like daily movements, right? So if you need to set up at a construction site, move the device on a regular basis, every hour, every 2 hours, every 3 hours, because you're constantly tracking or monitoring one specific thing, the tripod makes it super easy. You can just pick it up kind of like a terrestrial scanner, but with much more than the terrestrial scanner. So. Such as the real-time scanning, right? Like the real-time scanning, real-time video monitoring, real-time voice alerts, as we had mentioned. So via either through the app real-time alerts or through a radio, like a portable radio. So the person who sets up the device at a construction site, set up the tripod, carry the little remote with them.
The device.
Exactly, and they get an alert, so they know that they can say, "Oh, hey, go get over there. There's something that's about to happen. The crane is about to hit this person. You know, we need to make sure that does not happen." So
the people can move around freely.
Exactly.
And they still receive the immediate warnings.
Exactly. Another situation would be the external power source, right? So using the system in a fixed power source it can run indefinitely. So the system, being that it's waterproof, dustproof, it can work in scenarios such as this, where it's in the middle of the ocean on an oil platform, helping make sure that it maintains or pilots of boats maintain safe distance from the situation. So we'll get into more detail about that here shortly.
Yes.
So just to mention the LiProtect battery performance as we had discussed. So when coupling solar power and battery in real-time mode, which is like generating the real-time results, camera, everything, real-time alarm, 24/7, it has an endurance of around 48 hours when coupled with the solar. And then you can switch to balance mode. So for up to 10 days using solar and battery in the balance mode. And then in the power saving mode, up to 20 days. So really, this is based on specific scenarios. So solar and battery endurance without sunlight, continuous operation with sunlight.
Yes.
So it depends on, like you said, the customer's needs, the location of the device.
Yes.
That comes down to how it should be powered. So the B60 power is the one that we were talking about with the
temporary work.
Exactly, the tripod, moving it around, and then the external power supply, which is just continuous uninterrupted operation.
Yes. So one important part I want to expand on, because this is why we really enable long-term operation. The system includes a dynamic energy management. Yes, it automatically adjusts its working mode based on battery level. When the battery is full, it runs a real-time mode with LiDAR and camera and full performance, providing the highest accuracy and fastest response. And it can run for about 48 hours. And when the battery drops around 40%, it's switched to balance mode. LiDAR runs periodically, and the camera is turned off at night, extending operation up to around 10 days. When the battery drops below 20%, it enters power saving mode, only basic communications and low frequency sensing and maintenance, allowing the system to run for weeks. So I want to highlight it's one device, but we provide different modes to suitable for different scenarios. And when customers need the tower monitoring, they can choose the solar panel modes. When customers need to temporary monitoring, they can choose the battery modes. And then when customers needs the they can supply some external power, so they can choose the external power modes.
Exactly.
Yeah, so I think in it's the real world condition. This creates a self-adaptive systems that balance performance and endurance. So instead of talking more specifications, I believe everyone wants to see how it actually works, including me. Yeah, because this is the first time I saw the systems. Let's bring it to the site.
I think for the sake of time, maybe we just... So as we can see, the tripod is designed to be set up at several different heights. So if it's just wanting to keep it low or keep it high, we can preset that. It does have a level on it as well. So super simple installation. There's two red markers. There's a red marker here. We'll just take the device, go ahead and slide it into this spot here. Similar to our other products. Get it there and lock it into place. There we go, and it's tight so that we have the system set up as it should be. Super easy, super simple. Let's go ahead and just choose a target here, right? So we'll just choose this tree.
Yeah, we need a battery.
Yes. Battery, yes.
Battery. We just say it's battery mode for temporary monitoring work. It's our standard B60 battery, same as our LiMobile battery. So you can change the battery all the time, so you can perform the temporary monitoring work all the time.
Perfect. And so just a simple cable for the power. We'll go ahead and have this plug in first here on the power side. Drop this. There's an easy clip. Just slides in. And we're good. We'll go ahead and take this, attach it to the battery. Same as all of our other GVI products. We have that red to red. Boom. Good to go. The battery is similar to our other products. You just go ahead and one touch first. So I lit it up and then hold. And we'll see that the light goes and turns on. On this side.
You didn't open the battery?
Oh, yep, that's it. Yep. It looked like it though, huh?
Yeah, it works.
It looked like it the first time too, but...
So also
we'll
we
get a-
have a tablet.
Yep. So I'm gonna choose the target now. I'm just gonna turn it around so that we
Yes.
can get it set up at this little target here, which is a tree. But again, the target choice could be almost really anything, right? At this
Yes.
point, it could be small, it could be big. So we'll go ahead and highlight that we have the LiProtect server. So this is what is going to be used to do the communication with the device itself. So the Wi-Fi, we'll go ahead and it's generated. We can see that it says LiProtect, not generated yet.
Still during the initialization.
Initialization, there we
Okay.
go. So now we got 3 green
Complete.
lights.
Yes, 3 green lights.
I'm just going to toggle that on and off.
Maybe we can describe the. Did you describe the structure to audience?
No, actually.
Yeah.
Okay, there it is. Okay, so we'll go ahead and connect the internet real quick. So it's actually already connected, automatically connected. But we'll go ahead and describe this structure real quick. So we have the 3 different antennas: 4G, 433, and Wi-Fi. We have the power source input. We have the LAN input and an M10 input.
For data transmission.
For data transmission,
Yes.
exactly, whether it be by wired or by 4G, as we had mentioned. On the front, there is the LiDAR sensor as well
Yes.
as the camera, and it can be rotated and shifted and moved about so that it can be set up in the exact location that you
LiDAR
want it to
camera.
be at. So we have our LiDAR, and then we also have a camera, and you'll see what both of those are actually used for here in just a second. So we'll go ahead and turn it back towards that tree. I'll hit start using in this case. So it's going to open up the interface, which is a web-based platform that is actually being generated from the device. So from there, I logged in. It says LiProtect server platform. We have device management. We have tower management. So say I had 10 of these. I can see all of them set up. And then device management, I can see each of the individual devices. For this case, we have this one here that I'm going to go ahead and click on, which is the B009TS. I'm going to come over here and click this I. What that's going to do is pull me into the actual interface of this specific system. So now we're seeing this real-time stream of that tree that we just highlighted. And if I wanted to, I could, put my hand in front of it just like I did with the mobile system. And that way we can know that, it's active and not just a play. So what I'm going to do here is I'm going to choose electrify target initialization.
The monetary targets.
Exactly. So this is where I'm going to choose what type of target. So in this case, this would be used for like power lines, right?
Yes.
So if there's power lines near a construction site, I will choose those power lines one time, and then they're always going to actively track and monitor those set of power lines,
Yes.
which is very beneficial. So in order to do that, I'm going to come in here, I'm going to zoom in, get a better visualization of that, and I'm going to go ahead and I'm going to select on this tree. Or my fat fingers.
Did you create you need to create the target.
Oh, yep, point mode.
point.
Yep, sorry, brain farting after today. So, I think I need to zoom in a little bit more. Ah, there we
Yeah,
go.
you didn't
Yep.
click
I didn't click it all the way
Because we are
through.
cold.
Yeah, exactly. Brain is lost
Yes.
and cold. So we can see now the tree has been selected as the object. Remember, I was saying that power lines, but in this case, it's a tree. So I'm going to keep that tree there, right? I'm going to go ahead and hit complete. From there, this is now the object that is our target. This is what we are worried about being hit by someone, something, some object. So then we'll go ahead and save those settings, confirm that save. So now we have this interface that is the main interface that would be transmitted anywhere. So this device could be, let's say, 1,000 kilometers away. And I'm on my computer at home, and I see this interface that I'm looking at. And so
you can start monitoring.
At this point, it still just looks plain. We don't see that spot that I selected yet because of the fact that it isn't actively monitoring. Now we're monitoring. So we can see it is marked. These points are marked. And now we'll see as Louise walks into the frame, she starts to become this target. Now the device is actively tracking it. It's giving real-time visual feeds. Now it's an alert. She got too close to this tree. She needs to get away from that tree.
Yeah,
we need to scream at her, get away, get away, get away.
Sorry.
If there was the remote or that radio, she could be, or I could be far away as well, on site, and get that voice remote from there. So it's a super simple tool, super simple, but at the same time super effective. That AI side of of it is amazing. There's also an electric fence, so we can set an overall area. Say we want to be notified when something comes into a region, like a traditional security camera, but something that we're like looking at with high detail. Like we want this whole area to notify me the instant someone comes into it. Like we don't want someone getting into this before I know, you know, so instantly would be like, bam, okay, somebody's there, get the cops there, get, you know, whoever is there for your security purposes.
So we can even mount a visor on it or lighter.
Exactly,
on it
yes.
To say, stop close to our target, so we don't need to hire a person.
Exactly.
In the site.
Exactly, and the beauty of it is this is just one function of it, right?
Yes,
it's got many, many functions.
Yeah, we provide several modes. It's just one of the modes for temperature, temporary work.
Exactly. This would be the temporary one if we're setting up for like on the for long time use, right? We can have it set up so where that it tracks and it monitors and it updates us on a daily basis, on a weekly basis, on an hourly, minute by minute basis. It can do calculations, volume calculations, stockpile calculations. Exactly. So hopefully we have a little bit of time. We'll be able to walk through that for all those that are still with us today in this thing. So we'll go ahead and give this back to our partner here.
Because this product is mainly used for real-time monitoring.
Exactly. So real-time monitoring, real-time tracking, real-time, again, volume calculations, stockpile calculations, can all be done from a single device that's super user-friendly. As we saw, it was 2 seconds to set it up. I may have messed up at first, but
we can monitor it.
Exactly, from anywhere. So it's an amazing device, and maybe we'll get the chance to just briefly show some key examples, applications. So just to highlight what we were just talking about is the stockpile volume monitoring system, right? So whether it be indoor stockpile monitoring, so being able to actively track and manage indoor stockpiles, or trucks coming in and out of a mine, right? So as it goes in, it's full. As it comes out, it's empty. So being able to do active volume measurements in real time.
It needs long-term monitoring.
Exactly. So they can track how much they're making each day, right? Or how much is leaving the site each day, because it's like they know how much is in that truck. Where traditionally it's just bucket picks it up and drops it in, don't know exactly how much. This is giving real-time volume reports for that purpose.
Yes.
Another example would be the transmission lines that we talked about, which would be intrusion monitoring, right? So if somebody gets too close to the line, or if a vehicle gets too close to the line, it utilizes that AI detection to be able to accurately make sure that that person or that object doesn't get too close.
Yes.
Sends out an alert.
Yes. In this scenario, the system should be set on the tower.
Exactly. So, and as you had mentioned earlier, in a tower, in a situation, it can be up at the very top of the tower using solar power and battery power to give those accurate readings for that purpose. Another industry application would be the safety monitoring for live working near power lines. So making sure that objects and features don't get too close to the power lines, and deploying it at any time and anywhere is with an ultra-fast alarm response, right? So this is literally real-time notification saying, hey, stop.
Yes.
Stop, crane, don't go there.
Yeah.
Don't hit that line. You're about to take out a whole city's power by doing this, right?
Yes.
Like, we don't want that. Another would be that ship anti-collision monitoring system. So being able to actively track whether or not a ship is getting too close to a dock, or as traffic moves in and out, boat traffic moves in and out of a city. Sometimes in these shipping areas, they're so dense, there's so much traffic going through that
Yes.
accidents happen, right?
Yeah, the environment is very complex.
Exactly. Accidents happen, so being able to track it in real time, make sure those accidents don't happen, is going to save money and also save lives.
Yes, I think this scenario traditionally this depends on human judgment, which is not quantifiable. So LiProtect enables real-time distance measurement because we have LiDAR on that, and provides direct feedback, turning experience-based decisions into data-driven decisions.
Exactly. Overall, some other applications that could be used for rail safety. So when people actively cross railroads, especially here in China with the high-speed rail network, there's so many of them moving so fast and so often. So the earliest you can get a warning about someone crossing on these tracks is better. So if these systems are set up, you can get that early on. Another situation would be ecological monitoring. So monitoring landslides, potential
Yes.
landslides. You can set it up at a location where you know that there's a landslide and that it's slowly creeping or moving, and having this detect when those creeps happen, right?
Yes.
So being able to determine that. And then smart construction sites, right? So an overall construction site that in the future likely will be operated purely by machine control, by use cases without human intervention. Having a machine there that's also alerting all of these robotics at one time to a central command center will be something that's driven by something like the LiProtect.
Yes. Again, I think maybe the system installation is easy, and the app is very simple.
Yeah.
And maybe our slides is simple, but I want to say the device itself is not simple. We build in many AI algorithms in it, so it can have very smoothly workflow for customers. So I think it's a high potential product for all of our customers. Imagine that in every scenario you need a long-term monitoring. Yeah, instead of hire a person to protect this site, why not choose a low cost device to monitor and from the experience-based decision into data-driven ones.
Exactly.
Why not? Yeah.
Exactly. I could not agree with you more. I am super excited about the LiProtect. I think that in the future it will be also protecting myself from some event somewhere around the world,
Yes.
you know.
If you don't like the camera, we can even remove the camera. We only use LiDAR because we need the true distance between the object, right?
Exactly.
Yeah, so I think maybe we can back to the LiMobile data demonstration or our company introduction.
Yeah. I think we should find out the amount of attendees still.
Yeah, you mean the application, LiMobile application?
I think that.
Yeah, because I think we have some new user cases from our customers in using LiMobile.
Yes. Yeah. So jumping back to the LiMobile side of
Yes.
things.
Sorry, there maybe a little confusion.
Just rushing through it there to make sure that we stay
we
in
can
the
do
time
the
frame.
demonstration to our really new product, LiProtect.
Exactly.
So back to our LiMobile.
Exactly. So just highlighting a case study that was done in Thailand. So a pipeline design for a plumbing system. Utilizing LiGeoreference, LiDAR 360 MLS version 9 to do strip adjustment and effectively reducing data errors. Even after multiple repeated scans of the same area, the data remains high precision. So good high quality results from this. And then the smart parking project, right? So a case study that was done in Saudi Arabia based on smart parking. This was done with the M2 Pro. Super awesome data set that we received from the clients. The georeferencing, the coloring of the point clouds with trajectory adjustment so that they were able to create base maps for smart parking, right? So pretty much the future, right? So being able to smart park vehicles.
We think the spatial, really real spatial data set is very important for the spatial intelligent industries.
Exactly. Another one was also done out of Saudi Arabia using the M2 Pro, which was used for 3D models and volume calculations. So they were able to collect with the M2 Pro and generate volume calculation reports, leading to a very high dense point cloud and an overall result for the client that was above and beyond what they were hoping for.
Yes.
So I think that's the true power of LiDAR 360 MLS and our tools is being able to get true reports at the end of the day. You have your tool, you have your end solution, you have your end deliverable.
Yeah.
Clients tend to be mostly just focused on the end deliverable that you had said before.
That can be safe for stock ecosystem.
Exactly. And then another example was the HD mapping underground parking
Also
in
for
Chongqing.
the smart parking.
Exactly, in Chongqing, so specifically driven for autonomous driving and the smart parking, being able to do this in areas where, again, traditional mobile mapping systems would have failed. Encompassing our SLAM is what allowed it to work, so it's very beneficial that the LiMobile was able to work correctly. And then digital twins, so being able to create road scene modules, creating really 3D models or true 3D digital twins from mobile mapping data, being able to extract features, road markings, lane lines, physical features, and then creating these OBJ files that is like, you can drop it straight into a video game. You can collect with your device, drop it into a video game, or drop it into a mapping system, and be able to actively track or drive and train these self-driving vehicles on an entire citywide level of data. So another one would be railway safety analysis. So being able to put the M2 Pro onto something like a railway and being able to do clearance analysis, being able to vectorize lines, power line analysis, so whether or not power lines are a danger point, also running danger points as well, and a series of other tools like the cross-section analysis, being able to see deviations in the track line itself, is all super beneficial things that LiDAR 360 MLS can do when coupled with the M2 Pro.
Yes, we provide the automatic or semi-automatic tools to extract the railway lines.
Exactly.
Also calculate the difference, height difference on the railway.
Exactly, and just two more examples would be the section analysis that I had mentioned, but a vehicle passability analysis. So that the key of making sure that our cities are safe is knowing in advance when new things get into the way. So a vehicle passability analysis would be, can this truck make it around this corner, or are they going to hit someone on the corner when they pass it, right?
Yeah,
or are they going to hit a power line?
They can pre-calculate the
Exactly,
risk.
and we have several different models that they can use for the truck type and be able to do these types of calculations in advance to make sure that they're good. And then that automatic detection of like cracks and rutting with.
We just mentioned the player camera.
Exactly, the planner camera, and being able to use those images from the planner camera to automatically detect and annotate these cracks, so that the city workers or the construction company that has to go and repair these roads know exactly where they're at, so they're not spending all day trying to find these. They're clearly marked with exact GPS coordinates. So
our Australian customer uses this function very well.
Yes, repaired many roads.
Yeah. Oh, yeah.
They need to get out to Berkeley as soon as possible.
Yeah. Okay. I agree.
But yeah, so just to cover it, GVI as a whole enabled multi-industry applications driven by AI, geospatial intelligence, covering so many different industries. We could literally spend several days doing one of these webinars.
Yes.
24 hours a day, just covering what is totally possible with all of our hardware and all of our software.
Yes.
I'm super excited that we were able to cover so much today as it was. So and yeah, there's that. And then I think that we have one last little bit,
Yes. So Alright, so now we are moving into the final part of today. What we've shown so far is not just a series of our new products or our product line, but a complete infrastructure of spatial intelligence. This is what we call a full stack ecosystem, not just collection data, but enabling how space is understood, processed, and used. So maybe next I will have a brief introduction of our company. GreenValley was founded in 2012, originating from top-tier academic teams. Today, our products are deployed in more than 130 countries and regions across 4 major infrastructure sectors: power, transportation, forestry, and surveying and mapping. And we have over 140 core patents and software copyrights, and more than 300,000 professional users globally. So what we are building is not a single product line. We are building a system that connects device, cloud data, and intelligence into one unified workflow. So if we look at our journey, it actually tells a very clear story. From early software like the world's first commercial forestry software, LiForestry, and to our LiDAR 360 general platform for point cloud and image photogrammetry, and to LiProtect, and to LiMobile, our hardware, backpack, to LiAir, and now to full air-powered LiDAR systems. Every step has been moving in same direction, turning point cloud from something you can visualize into something you can actually use, and eventually something can directly create value for you. So all of this is built on our own technology stack, from algorithm to hardware and to software. So let me share some interesting example for from our hardware, how to create the true value. We use the multiple LiDAR platforms, for example, our LiAir, backpack, and LiMobile, to scan forestry regions across China, collecting more than 400 terabytes of data. So by combining machine learning with remote sensing, we cooperate with Peking University to map the Chinese tree density, building over 2,700 LiDAR plots. And we found that China has 142.6 billion trees, averaging about 100 trees per person. This is not just a project, it's a national scale capabilities. And here is another project I really like. We worked together with Peking University as well to discover a tree that is 20.3 meters tall. It becomes the tallest tree in Asia and the second tallest tree species in the world. And I always like one question. You know where's the tallest tree in the world, Cody?
California.
Which park?
Redwood National Park.
Yes, I think that's a very interesting collection because the tallest tree in America and the second tallest tree species in China, and now we have Cody and I in China to provide this webinar to all our customers, audience. Yeah, so based on our product line, our journey, and our algorithm, our leadership, so I have another question. Why GreenValley can continuously lead in this space?
Yeah, I mean, I'm happy you asked. So over the last year, we made major breakthroughs in both hardware, software, but really it came down to the version 9.1, 9.0 release that we've done. So LiDAR 360's version 9.1, individual tree segmentation accuracies of around 95% or more, ground point classification accuracies of 95% or more, image deep learning training, so being able to train the software with your own images with automatic vector and mask extraction, as well as SAM modeling, so segment anything modeled for structured classification and VLM modeling. LiDAR 360 is AI-powered LiDAR and photogrammetry processing platform. smarter, simpler, multi-industry, global downloads over 190,000 of them, numbers of features, 700 plus features within that software, and active users daily of 4,000 plus per region.
I think there should be 40,000.
I think so.
Sorry,
Yes, yeah. I think I was questioning that yesterday, but yeah.
Okay.
No worries. I know it's much more than that.
Yes.
That may just be the amount that I've done myself.
Yeah.
That I know of myself with my clients. So
Yeah.
yeah, but also LiDAR 360 MLS version 9.1. Some of the core breakthroughs, which was just released. Point cloud and image AI labeling, work efficiency increased by 99%, reaching up to 10 kilometers per person per day, where we also improved the SAM3 powered precision between 9.0 and 9.1, as you can see in the middle. The quality of the results speak for themselves, like the Gaussian splatting that we're seeing just compared to even 2-3 months ago is so much better.
Yeah.
And even the Revit for BIM reconstruction, so the real-time BIM modeling based on point cloud or 3D GS data that is capable with inside of LiDAR 360 MLS version 9.1 is unbelievable.
We are keep pushing ourselves to
Exactly.
better software, hardware to our customers.
Exactly, because it's never good enough. We're
Yeah.
never good enough. We're going to keep pushing ourselves.
Yes.
Because our clients
hungry.
are what need it. Exactly. Stay
Keep hungry.
And make it happen. So
Yes.
another breakthrough was our 3D Gaussian platform, right?
Mm-hmm.
So before it was just being able to view a 3D Gaussian
Yes.
model. But we really are one of the industry's first 3D Gaussian splatting model editing platforms. So we can do Gaussian classification.
Mm-hmm.
We can do automatic Gaussian object segmentation using that segment anything model that I spoke about.
Mm-hmm.
Gaussian noise editing, like Photoshop, but of
Yeah, like
Gaussian,
Photoshop. Yeah.
Gaussian splats. So taking a 3D
Yes.
real world, but with Gaussian splats. And being able to do water surface flattening editing and much more in this editing built-in module of our software. So
Yeah.
super excited about that. Another breakthrough was Powerline's version 9.1. The level of classification has increased up to 95% for main networks and secondary networks or distributions. This is like 85% of classification. 14 types including towers and cables. We added a substation model as well for fine inspection route generation using point cloud or using 3D GS models. So you can fly over with a drone, capture photos, create a
Yes.
photogrammetry, do your 3D GS, and create a fine inspection waypoint route to do more detailed analysis of substations. And then the AI-powered component identification for fine inspection of towers, right? So there's 40 plus model tower types that we can do these fine inspections. And as I spoke of earlier, being able to do a safety optimization. So
Yes.
making sure that these routes are safe. We can do that inside of the software. We can create the route. We can also run simulations to guarantee that the route is safe.
Yes.
You know, we have these optimization features built into Powerline that at this point I'm unaware of any other software that's capable of doing all of that. So it's an amazing thing. At the end of the day, GVI still stands on that full stack technological capabilities. Hardware plus software plus AI algorithms. One-stop solution tailored to diverse client needs.
Mm-hmm.
We're meeting needs from construction to forestry to power lines to crop management to BIM modeling
Mining.
to construction to mining.
Yeah. Yes.
So many different,
many different-
areas that we can
We
work
can
with.
have another 24-hour webinar to customers. What kind of application industries we can?
Exactly. And I just wanted to remember and remind all the customers out there and the people watching all around the world who stuck with us. Don't forget to scan that QR code if you want to get that
Yes.
free trial code.
Yes.
And also to find out more about GVI, follow us on LinkedIn, follow us on YouTube, on Facebook. Make sure that you stay in the GVI ecosystem and keep with us. But just the focusing on the 4 major industry applications. Again, energy inspection, transportation, surveying and mapping, and agriculture and forestry. GVI pretty much is offering you a tool that can do anything. So if you're
Yeah.
just getting into LiDAR or if you are an advanced LiDAR user, check us out. We have what you need. You just gotta reach out. So that info at GreenValley
Yes.
NTL.com. Reach out to us. We're more than happy to reach with you in regions all across the world. We're available pretty much 24/7.
Yes.
Reach out to us. So
Yes. So if we step back and look at everything we've presented today, the logic becomes very clear. Hardware solves how we capture spatial data currently. and the software solves how we understand and use the data. And together, this is why we call spatial intelligence. And one thing I think GreenValley has always insisted on is ensuring data reliability from the very beginning. So making sure every data set is trustworthy, usable, and deliverable. So before we close, I'd like to ask everyone.
Yeah, in your current projects, what matters most to you? Accuracy, efficiency, automation, or a mix of all of them. You know, feel free to drop in into the chat as well as send us messages.
Again, the QR code.
Exactly, and the QR code, which is up on the screen again.
Yeah.
Reach out. You know, we are looking to hear what you have to say and what you have to offer. We are constantly improving our software, our hardware. We tailor to customer needs. So let us know.
Yes, we can provide the solutions one by one because we have so many new products recently. So I think that's all for today. Thank you very much for joining us, and we'll see you next time. Bye.
Bye. Thank you, everybody.
Thank you.